Hello, everyone.
Hey, Andres.
Hey. So, it's 1 p.m. Eastern. I will give people another 5 minutes or so, to see who's showing up. It's kind of hard to get started, without the right folks, on the call, unless you guys want to, we can, because the way that it's structured, I just want to let you guys know, and maybe let me get going here with the initial starting point, which is actually, come on, load. Slow.
Looks like there's a lot of people in the ZK session.
Yes. Yeah, which is fine. They want that. Let me we're going to talk about that, but that ZK is not relevant to here. My sense is, I doubt that they're talking about Plonk and things like that. Let me just do this, share this, and then can you guys see my screen?
Yep.
Very good. Let's make this a little smaller. So this is going to be the starting point. Right, so this is really the 4 layers, the way that I see them. Again, this is just starting, so high level, and then the way that this is designed is to work through these 4 layers with regard to those 3 key questions, right? And some of these key questions might not be relevant to those layers, in which case we can simplify things, but for completeness sake, that's where it starts. So interface application layer, where you have sort of custom interfaces and API gateway and application logic, and then below that you have a middleware where you have workflows, identity, accounts, workgroups, messaging, and then the actual processing layer, we have a transaction pool, a virtual state machine, and storage. And then so that's your typical thing for you would have for like a loop ring or
it's layer 2 basically. I mean,
that's layer 2, yes.
Yeah, and then below that's layer 1.
And below is layer 1, exactly. Right, so nothing outrageous, but I think that it helps ground the discussion. We have Nick, who just joined us. Currently, there's no one. I mean, not no one, Nick, but it's like we're still giving people a little bit of time to join. Actually, let me jump over to the chat here and let everybody know that we are.
That makes sense. The client blockchain client improvement session is running a little bit on the long side. You may have folks that are in that are going to be joining you. The phone book is kicking off at the same time, and Zero Knowledge Circuits is also going into its second hour. So you might have some overlap there.
Yeah, which is totally fine. We can extend. We can start later. I'm just gonna hang out here until we can chat a little bit on general terms. But I'm not really gonna get the work started until we have the set of the right people here. Right.
Question while we're waiting. So John has brought up batching a few times, and I don't really know much about the concept, but I think it's something that Karthik was working on as an alternative scaling solution. Are batching and sort of traditional, or I don't know, traditional maybe not the right word, but the standard layer 2 solutions mutually exclusive, or could batching be?
No. This is part of layer 2. Batching just means that's what optimistic, that it's a roll up, right? A batch is a roll up.
Okay. But so Could baselines, whatever Karthik had in mind for baseline, be implemented on top of layer 2, so you can have scalability multiplied by batching? Or does that not make sense?
No.
Okay.
So the batching just means you have 1,000 transactions, and then you need to combine them somehow into one on-chain transaction.
Yeah.
Right, and that's the challenge here, because you want to bring down the transaction cost. So if you have 1,000 off-chain transactions, baseline transactions going into one on-chain transactions, obviously that on-chain transaction is $5. Your transaction costs drop significantly, and that's what you want to do. What you need to be mindful of is that you actually, and that's one of the key questions, is parallelism versus determinism, right? So if I have 10 transactions that are dealing with the same document, right? And as it changes hands,
Well, they have to be done in the correct sequence. Yeah.
They have to be done in the correct sequence. So if you have an MSA and you're kicking 10 orders off, and then you actually need to be mindful of the ordering, because of the sequence of the ordering, because different pricing might apply, right?
Okay.
So that is going to be handled the same way that Ethereum handles that, through nonces.
Okay.
So you're and it's going to be first come first serve.
So
right?
all of the transactions between a given set of entities have to be done in a specific sequence, but can entity pairs be parallelized? So like company A.
So if A and B and A and C, then those transactions that are independent. So think of them as like processing channels. They're workflow. So you can operate. You can run multiple independent business processes in parallel. So that's the advantage. So that's why there's a design choice that we need to think around. That is like, when you have a business process, it is probably worth to have that as its own account. That has multiple owners, which are part of the work group, because then I can manage the sequence in that account through nonces, and then I just evolve the state.
Okay.
Does that make sense?
I think so.
Right. So it's like I put in the MSA, nonce equals 1, right? And then I create the first PO, nonce equals 2, and then I create an invoice for that PO, nonce equals 3, right? Well, if I have then I have 2 POs, right? And then the question is, which comes first, right? And if they're cut from 2 different departments against the same MSA, right, then it's whoever comes in first, right? And then becomes a question, what are we going to use as a sequencing mechanism? Typically in Ethereum, right, you would use the transaction fee, right? The one who pays you more gets right. We don't have that here. So we need to talk about, are we going to use the timestamp? Is that the right timestamp? Is it are we right? So are we forcing everything through one identity, right? That needs to, so are you resolving the sequencing on the submitter side, and they just need to submit it drip by drip and say, this is I have, this is nonce 3, this is nonce 4, this is nonce 5,
right,
when I submit it, right? So I need to maintain my account in a wallet, right? That needs to take care of that. Or do I just, am I not making that, creating that complexity, but just simply dumping it on the client, on the baseline stack, to use something like a timestamp or a CRDT to create that sequence. right? So those are the kind of like, decisions we need to talk about when we talk about parallelism versus determinism. But anything that is not logically causally connected, you can run in parallel. So if you have 1,000 companies, right, that work with, then they can all run 1,000 transactions in parallel without having any issue. Right.
Okay. Cool.
Right. So it's only within one workflow, within one business process that's being repeated, that you need to worry about determinism.
Okay, that's good. Yeah,
does that make sense?
Yeah,
so,
and that's really helpful, because if everything had to be done in like one thread, it would be impossible. So yeah, that's important.
Right. So that's, I mean, again, a nonce is a possible solution, but it's a simple solution and it has been used before. Right. So let's not get fancy. Now, there is one caveat to that, right? And the caveat is, if you have what if you have set up, and this is sort of like, this is now you need to talk about the tech scenarios. What if you have set up, if you have to set up the same thing, right, with the same company, right, the same MSA, right, but on two different baseline clients, because and that's something that we need to think through. What if, let's say, Coca-Cola and FedEx, right, had or I don't know, Amazon and FedEx, or U.S. government and FedEx have set up a contract in MSA, right, and that is used by different departments. And these different departments use different implementations of a baseline stack, because, I don't know, the DoD doesn't like Provide and rather would go with Microsoft. And the Commerce Department doesn't like Microsoft and rather go with Provide.
Okay, but they're different clients, but they're connecting to the same network, right?
That is the question. If you're using the same MSA, right? And are there logical connections, right, in the MSA that constrain the sequencing on two independent baseline implementations? That's the problem. If we need to solve for that, then we need to synchronize. We need to synchronize. Then we need to synchronize a baseline network, and that is, then you're de facto creating a synchronized overlay network, and then you're creating de facto a kind of blockchain over another blockchain, right? Then baseline becomes a side chain, right? And then you have a problem again. How do you come to consensus, right? Then you need a consensus mechanism to say, yes, this is really, there's like, even though the DoD sent that thing in, it's not, and the Commerce Department sent in that PO against the same MSA, this is the right sequence, right? It's like, and we can, so it becomes really a question. It's really a business question. Do you have these scenarios, or not? If yes, then you need an implementation of baseline that is actually a network, right? And if not, then you can use a baseline implementation that is a single operator. Does that
single operator for every pair of companies?
No, so to keep with that government FedEx example, right? So if the MSA has no linkage about a specific type of product, right? In terms of then I can implement on Provide, and I can implement on Microsoft, right? Independently of one another. And then the Provide stack and the Microsoft stack for the US government doesn't have to be connected, because the MSA does not provide a coupling between the orders of those two agencies in terms of discounts.
I'm not seeing. So I'm assuming that all of the clients will be compatible. So I'm not.
That's not a given.
Okay.
So compatible in terms of the if there's a standard, yes. If there's a standard data model, yes. But the inner workings could be different, and there is currently no requirement that two clients need to be interoperable.
Oh,
But
okay.
even if they
assuming
are, sorry, apologies. Even if they are in the in the examples that Andreas you explained, we will still have a problem. Because I will draw the parallel. So if within a big company, there are two entities that use two different CRMs, right? One may use, I don't know, Salesforce, or even the same. One has its own instance of Salesforce, the other has its own Salesforce instance as well. And the data and the way the workflow and processes have been designed might be very different. So what you are saying here is that it's the same company. They may have like one contract, for example, the MSA, that has an impact or that is applicable to both Salesforce instances. However, the inner workings, so even if those stacks, if I go back to baseline, are compatible, like they are interoperable, that's not really the key challenge here, right?
No, the key challenge before we even get to interoperability, the key challenge here is does the MSA provide a tight business coupling between orders, for example? So do they create orders from different entities, different departments? Are they logically connected, right? So are they? Yes. Right. So that's the thing. If they are, then you're using different stacks, then these stacks need to be synchronized.
Yes, exactly. Right? So my question is, one of the solutions, or maybe I didn't understand that you are laying down, is that we should explore how to solve that like out of sync issue.
No, we don't. So my point is, because that requires so I think from a pure scaling point of view, that is not a problem that this work stream needs to tackle at the moment. That is a larger discussion of whether baseline clients should have a consensus algorithm between them as to submitted transactions or not. Even if it's just about consistency, right? Whether we require strong consistency of the transactions, of the submitted transactions between the different clients, or do we require eventual consistency, right? So that just means that if I've created a certain ordering, if one client has created a certain ordering, that is the correct ordering, right? And if other clients have other orderings, they need to follow that ordering.
Yeah. So to go back to the
that's strong
point,
consistency.
Yeah, about scaling. So if I'm part of a role group with two different workflows addressing two different business processes, within workflow I have a series of work steps that that are interdependent. However, we are saying that if I commit to or if I baseline every document part of the process, MSA, PO, invoice, etc., is there a way from a scalability point of view to batch, all of those steps together? So from a business point of view, I reduce the cost of the overall, workflow execution, right? Is it one of the, okay.
Yes. You can, and that's where the concept of like an ordering parameter, or a nonce, as it's often called, comes in.
Yes.
Right. So and then it's just a question, who manages that? Is it the submitter who needs to manage the nonces, and then the client tells you that ordering is correct based on what I have, or no, that ordering is not correct? right? So you can have you know, you can have conflicts in terms of like the nuns. So that's one area where that's why it's important that the clients order transactions, because in contrast to Ethereum, there is no transaction fee associated directly with the transaction, and everybody, it's a free-for-all. It's like no, here's a user, here's an entity that submits 1 or 2 or 3 or 4 transactions in a particular sequence, and the client just needs to ensure that that sequence aligns with what it has in terms of a sequence, so that
Yes.
the first transaction that was submitted is the current nuns plus 1. Right?
Okay, but there is an assumption here that the system of record time zone or time settings is aligned with the client, the baseline client, if you want to call it that way.
Client is the source, is the golden source.
The
baseline client is that. So the
question
has to be.
So if my system of record is SAP, and my record is created, my invoice record is created with a timestamp as per my own system, and everything that is timestamp and like ID sequence of those documents is like follows the logic of the system of record or the business rules, we are saying that this is not the source of truth. Our source of truth will always be the baseline client. Is that?
The baseline client is the source of truth with regard to the sequence.
To the
so
sequencing,
like,
okay.
With the sequencing, right? So an invoice is not finalized until it has been baseline, which means it has been checked that the invoice is consistent with the business rules that have been agreed upon between the two parties. Right?
Yes, that's
so
what
you
makes
might
sense.
you might have generated it, right? So you have a preliminary invoice, or you have an invoice, but you haven't sent it yet, right? To the
counterparty.
To the counterparty, right? That's a key thing, right? So if you haven't sent it yet, right? That's what baselining is. Baseline is, I am checking the integrity of the invoice against the business rules that have been agreed upon between both. So in case someone fat fingered something, you can say, no, that invoice doesn't conform, so you have to go rework, right? Now,
yeah, so if we follow that logic, one moment, it means that the invoice, well, we can only accept the validity of the invoice once it has been verified by the counterparty and the proof of the validation is on Ethereum. Then it is whatever timestamp is returned to the baseline client is basically the timestamp that we should use as proof, right? Not as proof, yeah, misleading, as ultimate confirmation that the cycle or the process or the work step, I should have said, is completed.
Yeah, let's stick with the example of the invoice. So party A creates a proposed invoice. That invoice is then sent to the baseline client and validated against the business rules.
Yep.
Right. That updates the state of the account to be proposed valid invoice. Right? Because you've checked it against the agreed upon business rules, and the invoice conforms to that. Right?
Yes.
Which means it's in alignment with the order that it was cut against, blah blah blah, right? And now you're once that is in, you then send that invoice via EDI, right, to party B, right, attaching the baseline proof. right?
Is there?
Hold
I
on,
know
hold
what.
on, not done, not done, not done.
Sorry.
Party B gets that message with the invoice and the proof. It goes and then checks the proof, right? Is the proof valid, right? Is the baseline proof valid, which it can do. That's a simple validation step. And then it updates the state on baseline of the document as invoice accepted.
Question. Is there a case where it could be designed where party A sends the invoice to party B directly, and party B is the one doing like the validation or doing the verification that the invoice is conform. Sorry?
Then I don't need baseline.
No, this is the baselining. And then when it's done, then the proof is added to the
But
Merkle
there's
tree.
no value. The business value, right, for party B is that it doesn't have to do that validate. It doesn't have to go against its own internal system of record, which might be incorrect, right? It just goes. It can rely on the baseline proof as the proof of integrity that the invoice has passed all business rules.
This is very specific to this use case, but
no, it's general. Any document, any business document.
Yeah, my point was not that they check against their own system. It's that they will deposit in their own system, not check that it's consistent with what they have because they don't have the invoice yet. So they receive the invoice and the serialized record. The check is done. And I'm not saying is that the right thing or not. I'm just asking if there are any circumstances or could there be any advantages to have those steps. So party A sends the record or the invoice, to party B. Party B just deposits the record, confirm, and then if everything is confirmed, the proof is deposited in the shield. For example, in the shield contract, it doesn't have to be. So, and if the answer is yes, it's no. Sorry, it's okay. I'm just asking the question.
So here, this is let me say here, this is sort of like the sequence. Maybe that's easier, right? So the invoice goes from here to the baseline, right? And then this is okay, then baseline, and the next one is then invoice validated, right? I'm going the happy path here, right?
Yes.
Right, so that's invoice validated, and this goes then to okay.
While you are drawing,
so that's receive. So and the next thing is this is party B is validate invoice, and that goes against here, and then the next thing is, and again, sorry if I'm drawing this. So if this is okay, this is the happy path, right? So if this is the happy path, so this is complete invoice mark invoice, right? And that's here, right? That goes here, right? And then the last one is then here is upload invoice into ERP of party B. Right, and this one informs here's also this is invoice accept that the acceptance notification to party A. Does that make sense? So you start here, you propose the invoice, it's baselined, invoice is validated, it goes to party B that validates the invoice against that, right? Then it updates the record here in baseline as accepted, right? So that gets party A gets notified, and then the stuff gets uploaded into the ERP.
Yes, it
not
makes
before
sense.
then.
It makes sense, and we are not saying like the only step. Sorry, that I did not include was the invoice validated the first time. So before party B validates, because I was thinking that if party A sign, party B sign, party B validate, and then the proof is that it's actually both parties have signed and accepted that the invoice is confirmed. Therefore, the invoice is baseline. So this I understand perfectly well, and it makes total sense. I was not arguing anything against that sequence. I was just asking if there is any case where the sequence that I have described can be applicable.
No, because then you have no business value, right? The business value is here that you can straight go to processing. There is no validation steps, so all the people that are doing invoice validation right now, that are going through that are things that do a two-way match or a three-way match between order, receipt, and invoice is no longer required, right? That matching is done in baseline, right?
Yes.
So you've externalized the functionality of your ERP into baseline, and you've simplified it, right? The goal in the end is that baseline becomes your ERP.
Yeah, okay, I'll be careful about this. I don't, that was not exactly the point that I was trying to make, but I get your point. I think we can move on.
So becomes your ERP with regard to intercompany commercial transactions.
Yeah, it's all about what are the acceptance criteria and what is the business logic within the circuit.
Right.
So I understand what you said. I think I'm not able to clearly explain, so it's on me what I'm trying to explain. But yeah, that makes sense.
If you can draw that, then that's probably helpful.
I can share.
No, you can draw in here.
Yeah. Yeah. True. I can draw in here. So let me go to the. Hold on. So I need to go.
So the key thing is that process you can run 1,000 times in parallel.
Yes. These are.
Right now, if you have multiple invoices, right, then you need to make sure that they are in the right. If you have multiple invoices between party A and party B, right?
I'm sorry, Andrea. Give me 2 seconds because this is lagging on my side for some reason when I open diagram.net, and I don't want to crash things because the other session starts in 20 minutes. So, I'm in now. So, okay, key invoice use case. Okay, I will start drawing.
Yeah, you can wherever you want to draw.
Invoice propose. I'm just doing below what you did.
And I'm sharing the screen so you can,
Yeah.
so task can see.
Invoice. So this is still going through the baseline stack for like the messaging component of the baseline stack. Then it is received by the baseline stack of the counterparty here. I'll just put it. Oh, this is lagging a lot. Up. So I'll put baseline stack party A. Oh. Is it on? Oh. Party A. Baseline stack party B. I think there is some lag, so apologies for this, but I'm actually typing. So I should have put system of record. So invoice sent. Received. Oh.
So what you're saying is you're just communicating the invoice through the baseline messaging system from
the first step.
From party A to party B.
Yeah, the first step.
Without any validation.
And yes, because for me, the validation and the value of the validation for the subsequent steps is to confirm that both parties, so the business logic of the circuit will be, for example, that we have agreed on a set of key fields that should match. And if we have to link that back to the MSA, so both parties are aware because the MSA would have been baselined already. So I can directly receive the invoice, verify this, and once I'm verified, because both parties would have signed already, it can be then, I will add it.
Okay, so where's that verification happening? Which system does the verification?
Here. It could be, that's what I was asking. I don't know the answer, or if that's the right way to approach it. It could be baseline stack. Sorry, no. I will, invoice received, and no, that would be here. Signed. Why do we have this twice? I'm confused. My bad.
So you're saying you want to send the invoice from A to B, have B sign it and saying, yes, I got it.
Yes, and then this is the stack. I receive the signature, and then this is where the verification happens, and then we can deposit. So this is, based on I send message, I sign, I confirm, I verify, boom, it's confirmed, then it's deposited.
Yeah, but okay. Your verification, and then you're signing it. What if the invoice fails?
So if the invoice fails verification, a message should be sent to both parties, right?
No, I mean, in your scenario, yes. In my scenario,
yes. Yeah.
In my scenario, no. Right. So in that scenario, only party A needs to know. It needs to rework the you're sending garbage. The key difference is, in your scenario, you can still send garbage over to party B. In my scenario, you know that you will never send garbage over to party B.
Again, if this is very, I think that there could be, I don't know, instances where before verification happened, both parties need to sign the document or the record. In that instance, I agree that one big value added of baselining is to check first before we baseline, before we confirm that there is consistency, that the two systems have the same invoice at the end. So I check against a first set of rule, okay, and then yeah, I mean it makes sense. Don't get me wrong, I totally get it.
Yeah, so I have done a lot of procure to pay, and like in Ariba and in SAP and Oracle and so forth. And what happens is that you check your invoice that you're generating against your data that you have based on the order you received, based on the receipt that you got, right? And then you match those up, and then you generate the invoice, and then you send that invoice over, so that party A to party B, right? But party A still needs to go and check that invoice against the order and the receipt that it generated to make sure that there was a three-way match, or it could be a two-way match, just the order and the invoice. And then payment is scheduled. So, but that still has, right? So, and then you typically send an acknowledgement. Yes, I got your invoice, right? So that's your kind of quote unquote signature. You don't do a digital signature there. You just send a message back. Yes, I got it, right? You still have no guarantee, because the two systems of records aren't synced, that what you received is not garbage, or not garbage, but does not align with your record, right? So the big advantage is if you send an invoice with a proof of consistency, right? And that proof of consistency is validated, right? You just, and then that the data on the invoice is accurate. The advantage is if you have an issue in your system, right? You send it in and then suddenly it gets flagged, right? You know that the invoice you got is correct, is the source of truth, not your system. And then you can change your system.
Yes, it makes sense.
That's the key. That's the key thing. Right?
Yeah.
And the key value prop is I don't need to do these checks anymore. All the documents back and forth are always. I know what I'll get is valid. I don't need to check it anymore.
Yep, that makes sense.
Right, and I can correct my books and records because some junior analyst fat fingered something in Oracle. It's like fat fingered an address or something like that, or there was a mass address update and it screwed up an address field. I will know that, right? That's the beauty of it, right?
It's yes. I think the way I was thinking for this is already thinking about the next steps. Like if a third party, for example, like invoice factoring company, what type of proof do I want? What do I want to check? What do I want to verify? It works okay for both, don't get me wrong. But I totally get it. So unfortunately, I need to drop because I have to sleep to the other one. Yeah, but that was helpful already.
Okay, cool.
Okay, thank you. See you on the other side. Breakout 6.
Yes, so to speak.
Yeah, thank you. Thanks. Bye.
Hey, Jörg.
Hi, how are you doing?
I'm good. This is a very intimate setting. We actually really haven't started that. We had sort of like some initial high level discussions around
workflow. I followed it on YouTube because I was in Track5.
Yeah, okay. So it was really primarily around how do you keep it's like the right sequencing, so determinism on state changes.
Yeah, I got that off. Yeah,
right.
Yeah,
so
got that off. Yeah.
Right. So
listen, I mute myself again because I'm in a very loud place.
That's fine. No issue. So I think so what I want to do, and we'll just get started. It's like this is now already 45 minutes in.
I have a quick question.
Yeah.
So you mentioned earlier that clients are not necessarily guaranteed to be interoperable. I mean, isn't that going to be kind of a problem if a large company has to run several different baseline clients in order to connect to different customers?
Well,
It
as
seems
long as
like-
each one is consistent, right? So interoperable means that, for example, you could use different types of proofs, right? So so for example, I don't know, an ENY stack would only support, zero knowledge proofs based on like Graph 16. And a Microsoft stack only, would do like only supports dark proofs or Plonk proofs, right? So they're different, right? So you would have to agree, yeah, you would need to, in order to do that, you have to support all these different schemes, right? So that's at the most basic level. It could even go further and say, can I send messages? So it's like, is the messaging system between two clients connected?
Yeah.
Right.
I mean, I could see why you'd want to have the ability to have different systems, different zero knowledge proofs and different networks. But on the other hand, it seems like part of the beauty of baseline is you only have to connect to one network.
Yeah. So again, I think that's the same question that you have with layer 2 scaling solutions on Ethereum, right? You can have just the one operator model, right? Or you have a model of an overlay network where you have multiple operators that stay synchronized.
Right.
Right.
Yeah,
So and both have their pros and cons. Right.
And I guess so. Theoretically, each client could support a different layer 2, right? I mean, like, you could have the Microsoft could use one layer 2, and Provide could use a different layer 2 for their baseline.
Yes, it depends on. It really depends on. So it really depends on what you're synchronizing on, right? Are you synchronizing on the? Are you doing it like with the? Are you synchronizing on a proof of correct execution as Ethereum does? Right. So Ethereum does all the processing, and then that block becomes, or that's the proposed block, and everybody needs to agree on that or not. Right. But that all the computations have been done. Right. So that is sort of like the hard consensus on state. Right. There is a softer consensus of just ordering. Right. Is there a consensus on the order of transactions? Because they might be relevant across clients, right? Because of the discussion that we had, right? You Microsoft or the government connecting to two different baseline stacks.
So you can't require that all connections between company A and company B under the same MSA be done with the same clients.
Yeah, because if you have very big companies, right, they have different. They might each business unit, right? There are different business units, right? AT&T has a 5G business unit. Then it has a voice business unit. They have different IT departments.
Yeah.
Right. So and they might make different choices.
Wow. Okay, that really complicates things. I mean, could you require them to run multiple clients if they? Could it be a requirement that in order to do business between company A and company B, they both have to agree on the same clients, even if that means running multiple clients on each side?
Yeah. So this is where interoperability comes into play, right? It's like, do I want to require that? Which means, I mean, just think about the when you're going switch sides and put yourself into the role of a CIO and says, it's like, wait a second, I need to run a Provide stack, and I need to run a Microsoft stack, and I need to run an EY stack at the same time. I don't want to do that. It's like EY is not even a vendor of mine. It's like I have to go through all this vending process, and just because FedEx is only using EY, that can't be.
Yeah, I mean, there's a lot of trade-offs. I guess on one hand, yeah, that's a big problem, what you just said. So it's better to have them interoperable. On the other hand, if they don't have to be interoperable, you could use different layer 2s and not be stuck on one layer 2 for the rest of time, right?
Well, you again, and then it comes back on what are you synchronizing on?
Yeah.
Right. Are you okay? So are you okay to send a message on a Provide stack over to a Microsoft stack, and then get it get a proof back from a Microsoft stack that goes into the provide stack that shows it to you, even though provide didn't generate the proof, it came from the ENY stack. That's the interoperability, right? So that requires vendor cooperation to define that, and that's, for example, what's being discussed right now in the communications business automation network, where we have pretty much exactly the same situation, where you have different applications from different vendors, and you don't want to have vendor lock-in. You want to be able to switch out different vendors if you want, and you don't want to have to run multiple stacks at the same time. So that's where this requirement for interoperability between different stacks comes in. But we're not discussing that here. I'm just saying this is it is relevant for scaling. If you're talking about how many messages can you handle, and is there a requirement that we need to, and that's less an issue here. I think this is relatively straightforward, but it becomes an issue here, right? On the middleware layer, because it's like on the messaging, once I have done the validation here and I see I don't have that customer in my stack, right? Then how do I find it, right? That's where the phone book comes into play, right? Okay. But can I handle 10,000 messages a second if I have 1,000 customers, right? Can I do 10,000 a second? 20,000 a second? Like, which type of messaging system do I need to utilize? So if I, for example, I know Kafka can handle it, or AMPQ, right? It's like they can handle that with the right setup. But do I need to, if I just needed to have that in one stack, that's easy, right? But if I need to replicate messages over to other clients, to other baseline clients, then that becomes more challenging, right? Then you're like, Kafka can do that, right? I can do that, right? AMPQ can also do that, right? It's like, or, you know, if you're using, for example, peer-to-peer, it becomes really hard because then you need to flood the messages across the entire network if you don't know all the clients, right? So the question is, do we know the clients, right? So the question is, if we have a phone book of validated identities, do we know all the existing clients? And if the answer is yes, we can have a more centralized approach, a more federated approach on the messaging side in order to reach scale. Then then if we're just looking at a single stack, right? Because I can internally scale, you know, that's easy, right? But if I need to replicate across, and I need to know, oh, the message was consumed, so I know, it's like, oh, I can't handle this message. It's like, you need to do that, right? But then who's the you, right? It's like where am I sending it off, right? To which Kafka broker am I sending it? Do I know that? Right, and that's where DIDs are important. DID documents, where I need to know the service endpoints, etc., etc., etc.
Okay.
Right. So that's where, for example, if I am Coca-Cola, right, and I run provide as part of my endpoints, right, I need to say I run provide. Right. So that if you're looking up, oh, okay, I need to specify in my message that it actually needs to go to provide, because Coca-Cola is operating on provide and I'm running on Microsoft. But then the Microsoft stack knows, oh, okay, Coca-Cola is not here, right? But there's a baseline message for Coca-Cola, but I know where to send it. It has to go to provide, and then you can negotiate. Then you have extended baseline on the messaging layer, but not below.
Okay.
Does that Does it make sense?
Yeah.
So Jörg, please chime in. I don't want to like, it's like dominate the discussion. So anyway, so I think that's the key question here. So where we have this, we talked about like interfaces, application. I think this is for this year transaction scaling. This is we just need to like ensure. So it's like the API gateway needs to scale, right? So, and this is then here also messaging, right? And here we need to say, we need to say, for single operator highly scalable.
Cool.
Okay.
I have to tip out for to take a call. I'll be back in 30 or 40 minutes.
Okay.
Cool. Talk to you later.
I'm just doing the. No, I'm not. You're still here?
Yes, I am.
So, any thoughts from your side? Ja, wir können es auch auf Deutsch machen, weil im Moment ist ja keiner. Sind wir beide die
Ich bin
Deutsch
an einem sehr lauten Platz im Moment.
Ja, das ist kein Thema.
Versuch das mal zu ändern. 2, 3 Minuten bitte.
Ja, kein Thema.
Nein. Es ist, sorry, das habe ich ausgerechnet jetzt. Das ist immer das Gleiche.
Wir haben ja jetzt Nachrichten einmal geguckt oder wundern wir jetzt aber nach oben.
Sind schmaler die Dinger? Lass das einfach mal so stehen. Esse das dann weiter, wenn ich wieder komme.
Du musst es den Dimmofen machen. Was machst du jetzt?
Ich gehe mal woanders hin. Weil jetzt kann ich gerade mit dem reden, weil wir ganz alleine sind. Die anderen sind ja alles im Meeting raus.
Ach ja. Okay, das ist beschäftigt, du sagst.
Ja. So, jetzt bin ich wieder da. Kann man mich hören?
Ja, ich höre dich.
Ja, okay.
Du kannst übrigens in das File reingehen. In den Instructions ist der Link zu dem
klasse. Ja.
zu dem File hier. Lass mich das mal ein bisschen kleiner machen, damit man das besser sieht.
Der ganze Teil Middleware, zumindest jetzt der zuletzt, wieso kann man das nicht in den ERP-Systemen machen? Also, oder anders gefragt, Middleware ist jetzt nicht gemeint als das Mainnet als Middleware, ne?
Nee. Das ist hier. Es geht hier rum. Das ist der Stack. Weißt du, du hast ein Interface Application Layer und dann erst hier ein Middleware Layer. Da hast du deine Workflows drin, die Definition von den Workflows, die Identity Accounts und Workgroups und dann Messaging. Ja, weil das brauchst du hier für, wenn du hier die Application Logic hier fürs ACL, ja, um zu checken, ob du die APIs callen kannst oder nicht. Ja, und dann hier Messaging. Das ist weil da ist eben die Frage, ist das eben nur innerhalb von einem Stack? Dann, was weiß ich, benutze ich Kafka oder RabbitMQ und dann kann ich das hoch skalieren, wie ich will. Ja. Aber wenn ich jetzt die Messages zwischen unterschiedlichen Vendors hin und her schieben muss, weil du zum Beispiel, du hast Bosch arbeitet mit Microsoft, mit dem SAP Baseline Stack zusammen und BMW mit dem Oracle oder mit dem Microsoft, ja. Da musst du ja irgendwo und Bosch möchte jetzt nicht mit Oracle, weil die keinen Bock drauf haben. Das heißt, SAP und Oracle müssen sich auf ein Messaging-Protokoll oder mehrere oder einigen, sodass ich weiß, dass SAP eine Message, die für BMW gedacht ist, von Bosch auch empfangen kann.
Ja.
No? Das ist die Frage. Und das Problem, wenn du P2P hast, dann ist das super gut, wenn du permissionless bist, aber wenn du weißt, wer deine einzelnen Vendors sind und weil die sowieso im Phonebook sind, ja, weil die sowieso im Telefonbuch drin stehen, dann kannst du auch sagen, dass du was benutzt, was besser skaliert als zum Beispiel P2P. Ja, sodass du da wirklich 10.000 Messages pro Sekunde durchhauen kannst. Ja, also nicht nur innerhalb von einem Stack, sondern auch replizieren kannst.
Ja.
No? Das ist die Frage. Aber jetzt hier so, mit wem arbeitest du zusammen?
Ich bin unabhängig. Also ich habe meine Firma verkauft und wir haben seit 2009 ein SAP-Add-on für Vendor Invoice Management.
Ja.
Alles inside SAP, also rein in SAP. Inklusive Interpretation der papierhaften Rechnungen, die gescannt wurden und dann OCR verhaftet wurden. So. Deshalb bin ich auch ein bisschen auf dem Trip nach wie vor, dass man das von den Backends her, also von den Endsystemen her steuert. Und was ich an Baseline halt total gut fand, ist, also, dass das nicht wieder über eine Konsortial-Blockchain läuft, sondern wirklich das Mainnet. Und bin aber zugleich nach wie vor ein Anhänger davon, dass zum Beispiel das ganze Processing also gar nicht über einen jetzt kommt gerade aus der anderen Session, nicht gerade, aber war in der anderen Session, nicht über einen bestimmten Client laufen muss, sondern okay, natürlich in irgendeiner Art API vorausgesetzt, mit RESTful-Aufrufen einfach aus entweder Oracle und man unterstellt, die können das, SAP kann es jedenfalls.
Ja, Oracle kann das auch. Das ist kein Thema. Ja, das kannst du als mit Hilfe von einem SDK und so. Das ist kein Thema. Aber die Frage ist, machst du muss ich als, was weiß ich, Bosch, was weiß ich, einen SAP Baseline Client laufen lassen und einen Oracle Client und einen Provide und einen Microsoft Client laufen lassen? Oder kann ich das, also was weiß ich, muss ich mich mit 4 Software-Anbietern auseinandersetzen oder 5 oder 6 für Baseline oder nur einen, weißt du?
Ja, aber das habe ich insofern jetzt auch aus der Diskussion vorher nicht ganz verstanden. Das ist doch eine Frage, die auf Protokolllevel definiert werden muss, kann.
Ja, natürlich.
So.
Aber
und in dem Moment, wo sagen wir mal, Besu würde das nicht unterstützen, dann fällt Besu halt als Client halt raus.
Nee. Das ist Besu als das ist hier unten. Das ist hier unten. Ein Baseline-Client, der ist hier. Das ist der Baseline. Das ist sozusagen der Baseline-Stack. Das sollte ich vielleicht noch das sollte ich irgendwie als vielleicht nochmal irgendwie so kräftig
mein Screen sharen?
Darstellen. Warte mal. Das ist ist nicht so gut. Warte mal, habe ich da noch was ich benutzen kann? Habe ich da eine Klammer? Ja, Klammer hier. Super. Das ist genau das, was ich gesucht habe. Das ist der Baseline Stack. Das ist der Baseline Stack hier. Das wollte ich nicht.
Ja,
das wird aber als höher, genau. So, das ist der Baseline Stack. So, und das ist hier eben alles nur public. Und da hast du Probleme, du hast Probleme hier. Das ist nicht das Problem, das ist auch nicht das Problem, aber du hast, was die Transaktionen von die angeht, ist das hier ein Problem, weil du im Mempool, das ist der wilde Westen. Und da geht es dann nur darum, wer mehr zahlt, und da gibt es dann noch 50.000 unterschiedliche Angriffsvektoren, die du da machen kannst. Du kannst dann Frontrunning, wenn ich weiß, welchen Smart Contract das kann ich da, also möglicherweise, also das ist dann Detaildesign für deine Smart Contracts. Da wird's dann wichtig. Und das ist eben, die Frage ist, also das ist fürs Scaling ist es wichtig, und dann hast du natürlich hier, da kriegst du die ganzen Transaktionen hin. Ne?
Ja, vielleicht bin ich auch etwa auf dem falschen Trip. Äh, sagen wir so, sämtlich ja, hatten eher High-Level-Slides von Baseline. Die zeigen ja, also von Daniel Norkin, die zeigen ja letztendlich, oder auch Consensus auch, die zeigen ja letztendlich, dass an jedem ERP-System unten eine Schicht Baseline, wenn man so will, Plugin
Ja, genau.
was
Das,
genau
das
dieser
hier.
Stack wäre, ne?
Ja, das ist der Plugin. Der geht dann zum API Gateway. No? Das ist dein SDK, da hast du dann dein App, dass du einbinden kannst dass du dann zum Beispiel in dein Workflow, dein SAP Workflow einbinden kannst.
So, und ja, okay. Also ich sehe die Punkte da, aber vielleicht gefällt mir das nicht, dass ich nochmal eine extra Middleware brauche, um das Ganze durchzuführen.
Ja, das ist ja Baseline Stack intern. Du baust es ja nicht in den. Ich meine, du kannst das Ganze natürlich in SAP einbauen, wenn du möchtest. Ja, klar kannst du das machen. Nur du musst dann das
Messaging, das ist ein extra Punkt. Das ist logisch.
Ja, also aber du kannst das mit reinbauen, aber allerdings sind die Sachen hier, das musst du klar, das kannst du
das ist traurig, ja.
Da musst du richtig für arbeiten. Also das ist ein Add-on. Deswegen, das kannst du als SAP Add-on machen. Aber da brauchst du halt Techniken, die sozusagen nicht SAP Native sind. Ne? Das ist auch klar.
Ja.
No?
So, jetzt sagen wir mal, den Baseline Stack gäbe es als Stiftung. Ja, sodass
den gibt's. Es gibt eine Referenz Implementierung.
Das kenne ich alles. Aber sagen wir mal, das wäre wie im Führer nur kostenlos. So.
Ach so, du meinst naja, also kostenlos kannst du es ja nicht machen.
Lass uns mal egal. Ja, klar, das soll ja nicht kostenlos. Aber sagen wir mal, das gäbe es und man könnte es aufrufen. Jetzt wird mal ganz getrennt dann wäre das eine API, wogegen ich meine Workflows, die Identity sowieso, das hatte ich verstanden, das ist ein Smart Contract auf der Public Chain. Messaging außen vor, das muss man dann definieren zwischen Bosch und was war das andere? Auch egal. Müllermilch von mir aus.
BMW hatte ich, das war das
BMW.
Beispiel.
Und dann
ja, also für Scaling ist das hier wichtig.
Das ist dann eine andere Story.
Das ist hier der Workshop hier, da geht es ums
Ja, ich weiß, deswegen, ich wollte eigentlich auch nur zuhören und lernen.
Also hier geht's um Scaling, da geht es eben darum, was du da benutzt. Welche Scaling. Du hast eine Spreizung zwischen deinem Throughput und deiner Privacy. Ja, da können wir, das ist, weil du musst nicht alle Transaktionen unbedingt auf die Chain schreiben. Ja, das ist zum Beispiel, wenn du, was weiß ich, eine Shipping Notice oder sowas hast. Ja, das ist wichtig als Update das zu machen, damit du weißt, dass das da ist, weil wenn irgendwas später schief läuft, wirst du sagen, ja, aber hier Shipping Notice kam. Das ist wichtig, aber das muss ich zum Beispiel nicht als Zero Knowledge Proof auf der Chain haben. Da würde es reichen, wenn ich irgendwie eine URI auf der Chain habe, die dann, was weiß ich, zu einem Merkle Proof zeigt, und ich kann das sozusagen dann ist das irgendein Eintrag, ist die Shipping Notice ein Eintrag in einem Merkle Tree, und der Eintrag ist verschlüsselt, und das war's, ja. Dann hast du und das skaliert hoch. Wenn du allerdings zum Beispiel eine Rechnung haben möchtest, und die Rechnung möchtest du dann zum Beispiel fakturieren, ja, oder eine Bestellung, und die möchtest du dann zum Beispiel für einen Kredit benutzen, ja. Oder du möchtest eine Rechnung, die du bald bezahlt bekommst, benutzen für eine Bestellung. Du sagst, dass du, ja, ich kann die bezahlen, weil ich bekomme das jetzt. Ja? Diese Art von Geschäftsprozessen, da müssen die Dokumente sozusagen on-chain sein. Und da brauchst du dann diese Zero-Knowledge-Proofs. Na? Also, und da brauchst du dann für Skalierung brauchst du dann CK Rollups. Ja? Da reichen die Optimistic Rollups nicht. Ja. Also wenn es um Wertschöpfung geht. Und das ist, aber das heißt, du brauchst dann im Endeffekt du brauchst zwei unterschiedliche Arten, um deinen Geschäftsprozess sozusagen zu typisieren, oder beziehungsweise die Dokumente in deinem Geschäftsprozess. Also der einen, wo du das alles nicht on-chain brauchst, und Dokumente, wo du es on-chain brauchst. Ja. Und dann musst du die beiden verbinden. Und die Verbindungen sind dann, was weiß ich, dann sind dann Hash-Proofs oder Merkle-Proofs, die du dann als Input in deinen General Prover Service machst. Ich weiß nicht, bist du vertraut mit CK Snarks oder sowas, oder nicht?
Ja, wir hatten ja diese Diskussion in dem Chat, wo du auch eben nicht so, also nein, anders. Das war ja schon damals in dem Chat meine Frage. Ja. Wenn ich noch anders gesagt, die Workflows, um die es geht, die müssten per Definition enthalten, welche Schritte unter welchen Bedingungen abgearbeitet werden, so dass zum Beispiel ein Lieferavis nicht übers CK-Proofs laufen muss, am Anfang die Bestellung zum Beispiel, aber schon, und vielleicht sogar der Wareneingang. In jedem Fall aber die Rechnung. So.
Ja, das ist die Definition für hier. Das ist die Frage, benutze ich dann ein Programm, so ein General Prover Programm, für ZK Rollups oder für ZK Snarks, ja, gegenüber zum Beispiel Optimistic Rollups. Ja. Oder kann ich sogar noch einfacher machen, weil ich ja da wirklich keine Wertschöpfung, keinen Wert auf die Chain schreibe. Kann ich das noch einfacher machen, indem ich einfach nur einen Pointer zu einer URI mache? Also bei Optimistic Rollups schreibe ich immer noch die Transaktionen, die Unterschriften für die Transaktion als Hash-Proof auf die Chain. Ja, das heißt, du musst dann gucken, ob du dann auch wirklich derjenige bist, der normalerweise ist der Nachteil ist, dass jemand dauernd drauf gucken muss. Weil wenn jemand einen Block reinschreibt mit einer Unterschrift von dir und du hast es gar nicht gemacht, ja, dann musst du gleich die Hand heben und sagen, nee, das geht nicht. Ja? Das ist nicht wahr. Du kannst...
Wie sollte das einer können?
Ja, du weißt ja, ob du was unterschrieben hast oder nicht. Da gibt es wenn du dir, was weiß ich, anguckst, zum Beispiel ja, Optimistic Rollup-Varianten, zum Beispiel Validium oder sowas. Da ist die sozusagen die Grundbasis ist ja, dass du die Unterschriften von den Transaktionen als Aggregation auf die Chain schreibst. Und du hast aber nichts über die eigentliche Transaktion. Keine eigentliche Transaktionsdaten. Und das ist der Unterschied zu ZK Snarks. Bei ZK Snarks hast du das, weil du hast das Ganze in einen ganz kompakten Beweis reingeschrieben.
Ja.
Und den Beweis kannst du überprüfen, auch on-chain. Und das ist ja das Schöne.
Der Witz da dran. Ja,
das ist genau der Witz. Das heißt, du weißt genau, dass es richtig abgelaufen ist und dass das alles mit rechten Dingen zuging. Und dass der Operator kann den Beweis nicht fälschen. Während bei Optimistic Rollups, da könnte der Operator die Unterschrift fälschen.
Also ist das dem Prinzip nach doch keine Lösung.
Die Optimistic Rollups sind für zum Beispiel Bestellungen und Rechnungen keine Lösung. Da brauchst du meiner Meinung nach die ZK Rollups. Aber was weiß ich, für eine Shipping Notice oder Return Receipt oder solche Sachen, da kannst du eigentlich alles Off-Chain machen und musst dann nur in einfachen Anchor-Proof mittels URI und Merkle-Proof auf die Chain machen. Das ist alles. Und dann kann jeder das überprüfen und das ist relativ unproblematisch. Und dann ist ein Input-Parameter für dein ZK Snark, was weiß ich, ist dann, dass du für die Invoice muss dann eben eine Shipping Notice da sein, zum Beispiel. Und das kannst du dann ganz einfach über den Hash machen. Ja, und dann kannst du das reinschreiben und der Hash muss dann eben bestimmte Charakteristiken haben. Ja. Also, und das ist relativ einfach. Oder es muss ein Aggregate, was weiß ich, sein, den ich dann irgendwie on-chain, dass ich irgendwie überprüfen kann in meinem Prover-Programm, das ich für den ZK Snark geschrieben habe. Und das geht. Das ist kein Thema. Insofern kannst du die kannst du also sozusagen zwei Parallelwelten, einmal mit was weiß ich, mit diesem einfachen Batching oder non-financially sensitive Documents kannst du dann, da brauchst du wenig Daten on-chain. Das Problem mit den ZK-Snarks ist, dass du also, was ist es? Also ich brauche im optimalsten Fall, wenn ich ein ZK-Rollup mache mit 4500 Transaktionen, sind es im optimalsten Fall knapp 0,9 Megabyte Daten, die ich auf die Chain schreibe. Im schlimmsten Fall sind es 2,2 Megabyte. Das hört sich jetzt nicht unbedingt viel an.
Es wird aber teuer in der Sinne.
Aber das ist es ist nicht teuer von den Transaktionskosten. Du spammst die Chain. Weil du kannst ja mal machen. Mach das mal, wenn du 1000 Transaktionen, Roll-up-Transaktionen machst, dann bist du bei 1000 mal 4500, sind es 4,5 Millionen Transaktionen. Das ist jetzt nicht so wahnsinnig viel, aber das sind dann schon 1000 mal 2,2 Megabyte, bist dann auch schon bei 2,2 Gigabyte. Und das könntest du gegebenenfalls locker am Tag abfackeln. Gegebenenfalls noch mehr. Das heißt, wenn du dann bei 4 Milliarden wärst, dann machst du es nochmal mal 1000, dann bist du bei einem Terabyte, dass du pro Tag drauf schreibst. Und das ist problematisch. Ja, weil ich schreibe dann alles drauf und dann so, wenn alle in der Welt draufschreiben, dann wird die Datenbank natürlich auch relativ schnell voll.
Ja, gut, jetzt Folgendes, Andreas, aber für mich sind das wirklich Layer 2 Fragen, ne? Da kann ich kaum mitreden.
Ja, das sind die
ich weiß, dein Workshop geht eigentlich genau auf das.
Genau.
Ja.
Du kannst gerne bei ich wollte das einfach nur mal erklären, wie das aussieht. Ich warte, ob noch Leute kommen. Und wenn nicht, dann ist es anscheinend, dass keiner dran Interesse hat. Andere Sachen sind.
So nicht. Ich glaube eher, dass das vielen so geht wie mir, dass man erstmal die Basics von Baseline mehr verstehen muss. Das ist, was du gerade ausgeführt hast, entscheidend wichtig.
Ja, das stimmt.
Ich meine, ich folge dem Baseline-Projekt seit Beginn, also seit März. Und das ist nie aufgekommen so. Ne?
Nee, das ist richtig. Aber das ist ja die Kernfrage ist, zum jetzigen Zeitpunkt kostet dich jede Transaktion irgendwo zwischen $2 und $4.
Ja, alles gut. Jetzt einerseits, das mag für einen Bosch oder BMW aber auch nicht viel sein, weil für Invoice Verification
geben sie aber überleg mal, wie viel Bestellungen macht Bosch am Tag? Stell dir mal vor, wenn du 10.000 Bestellungen durch Baseline durchlaufen lässt. Allein nur die Bestellung, das kostet dich dann 20 pro Tag. Das kostet dich dann $20.000. Das ist viel Geld. Stell dir mal vor, für eine Bestellung, die ich faxen kann, ja, quote unquote faxen oder e-mailen kann, das kostet mich ja nichts quasi. Ja. Da muss ich $2 für zahlen. Da guckt dich der Finanzvorstand aber ganz, ganz schnell, ganz, ganz schräg an.
Gut, einerseits, andererseits, so ist es im Moment wegen den High Gas Prices. Right?
Ja, aber das wird sich ja nicht ändern. Das wird ja, das wird ja höchstens schlimmer. Ja, das wird ja, als es ganz schlimm war, als DeFi ganz, ganz oben war, hast du, wenn du Fast Confirmation, musstest du $200 oder mehr pro Transaktion zahlen.
Ja, okay, das ist ganz große Finanztransaktionen.
Ja, du hast die Abhängigkeit.
In der Masse wird es nicht machbar.
Ja, aber das ist eben, genau, das ist eben das Problem, das ist die Problemstellung, wenn du auf einem ein Protokoll benutzt, wo du als dein Anker, wo jeder drauf zugreifen kann. Und wo andere Programme auch laufen, die gegebenenfalls höhere Priorität haben als deine. Du kannst dann, das ist ganz toll, ja, wenn du sagst, ja, Public Infrastructure und alles Mögliche und alle finden das ganz toll, aber dann mal gucken, wenn du eben Rabauken hast auf der Autobahn, dann ist die Autobahn auf einmal auch nicht mehr so toll. Und das ist genauso mit Ethereum. Ne? Das ist also im Mempool, das ist absolut der wilde Westen. Wenn du mal guckst, was da abläuft, das ist unglaublich.
Das habe ich auch, das verstehe ich alles, ja. Das ist,
und deswegen ist es sehr kritisch, dass du oder ist es extrem wichtig, dass du die Transaktionspreise runtertreiben kannst, damit ich eben, was weiß ich, $600 für eine Transaktion bezahlen kann. Und dann kostet es mich aber trotzdem irgendwie nur 10 Cent oder 1 Cent oder noch weniger.
Ja.
No? Das ist der Krux an der Sache.
Dann ist aber das Fazit eigentlich,
Baseline zum jetzigen Zeitpunkt ist nicht skalierbar. Das ist ein Spielzeug. Ja, ohne Skalierung ist Baseline, ist es nicht wirklich benutzbar. Ja, du kannst jetzt das Prinzip demonstrieren und das funktioniert auch und du kannst das als Proof of Concept und so, das ist alles gut und schön, aber in der Produktion, wenn du da wirklich anfangen möchtest, ich meine, wenn du es nur für zum Beispiel benutzt für Bestellungen über 10 Millionen Euro oder sowas, ja, dann kannst du das sicherlich benutzen. Wenn du dann nur was weiß ich, 2, 3, 4 Transaktionen am Tag hast oder so. Und die sind alle extrem hochwertig. Ja, also mit einem sehr hohen Betrag. Dann kannst du das, dann ist es okay. Aber
ansonsten, das ist aber im Projekt. Meinst du wirklich, dass das im Projekt so verankert ist?
Was?
Diese Ansicht? Oder dieses wirkliche Problem?
Ist
ja aber auch egal. Jedenfalls, das stimmt. Das ist in gewisser Hinsicht, Stand heute ist es ein Showstopper.
Ja, klar ist es einer. Deswegen habe ich ja den Track ja auch gemacht. Und deswegen habe ich das ja auch als Business-Motivation reingeschrieben. Wenn das keine Leute interessiert, ist das so, kann ich auch nichts für.
Nochmal, das glaube ich so rum nicht. Man kämpft so wie ich eher mit den Basics des Proof of Concept.
Ja,
zumindest jedenfalls alle, die nicht unbedingt in den Prototyping drin sind im Moment. Ja, ich kann dazu ja nichts liefern zum Beispiel.
Ja, klar. Ich meine, das ist schwierig, wenn man jetzt gerade erst anfängt, da erstmal durchzusteigen. Ich meine, der Stack ist nicht gerade, der ist komplex.
Ja, leider. Ja so. Und das muss man mal durch die anderen Tracks gucken irgendwann.
Die anderen Tracks, die sind mit Ausnahme von den Core Interfaces, ist es eben, die sind High Level. Da ist wirklich der Phonebook und was weiß ich, Tokenization und so. Ich weiß jetzt nicht, wie es mit Tokenization aussieht. Müsste ich dann mal.
Naja, das ist ja auch noch nicht ausgegoren.
Mal reingucken.
Das ist,
Ja, klar, aber da brauchst du diese Zero Knowledge Proofs, um dann du musst die ganze Smart Contract Architektur muss geändert werden, ja. Die Baseline Smart Contracts die können ja noch nicht mal upgegradet werden. Das geht ja alles nicht. Du musst das komplett neu implementieren und das ist ja Schwachsinn. Ja, das heißt, da muss auch drüber reden. Das will auch keiner, beziehungsweise will schon, aber du brauchst dann eben Leute, die technisch wirklich versiert sind, um diese Diskussion überhaupt führen zu können.
Ja. So, ja, wie damals in dem Chat schon, es wäre überhaupt mal schön gewesen, wenn das Protokoll zumindest mal in den Grundzügen, also das, was
ja, das ist ja das,
was Dan auch macht gerade, das mal wie high-level-mäßig auch immer zu definieren in seinen Steps und fertig.
Ja, ich meine, deswegen gibt es ja die Standards Working Group. Da wird das ja jetzt gemacht und da werden die Standards jetzt festgezurrt. Also das ist ja jetzt alles am Anfang, ne? Und es gibt eine Reference Implementation, das war's. Ich meine, und ist das einfach? Nee. Weil du hast die unterschiedlichen Komponenten und die sind alle nicht trivial.
Ja.
Ist nun mal so. Ja, kann ich auch nichts machen.
Nee, das ist ja wie soll es auch anders sein? Das ist ein Feld eigentlich vom Himmel.
Ja. Jordan, my friend.
Yeah. So we switch to English and I go to listening mode?
No problem. I had a question, that's why I came to this session, but
yes, sure, go ahead.
Sure if I'm interrupting you because I
No. We're kind of winding down.
So this is about the improvement of the baseline protocol, or
yes, this is performance improvement in order to get the transaction cost down.
Okay, yeah, I have what I don't understand is, say there's a frequent mention of this baseline being a public Ethereum blockchain, right?
Well, baseline is a stack on top of the public Ethereum. Yes.
Okay. So
let me share. Let me share. Resume sharing. Can you see my screen?
Yeah.
So think of baseline. So baseline are the first three layers. There's the interface application layer, there's a middleware layer, and there's a processing layer.
And then everything is written in the Ethereum blockchain, supposedly. Yes. Ethereum. Okay.
Yes, exactly.
Now let's go to Ethereum 2.
Okay.
Eventually it's going to be on Ethereum 2, right?
Yeah, but I mean, right, ETH2 phase 0 is just the beacon chain.
Yes. Okay, but there's one great inefficiency that I see here. Basically, all you're writing to the blockchain is a bunch of zero knowledge proofs.
That is correct.
Well, zero knowledge proof doesn't have to be idempotent, like spending money. So think about, you have one Ether, you go to one shard and spend it, and then you go to another shard, you can't spend it again. So there has to be a lot of work done, and thus the complication of Ethereum 2, for those shards to sort of eventually sync up. Whether it's optimistic rollups or ZK, doesn't matter, but somehow they have to get in sync, so you cannot spend that Ethereum twice.
That is correct. That's why you have.
That's right. But you don't need that in the baseline.
No, you don't need that in.
So if you submit a zero knowledge proof twice, there's no problem. So you can submit it in 2 different shards. So eventually,
yeah. Totally. For baseline, even for scalable baseline, you don't need ETH2.
okay. So basically, baseline can be a completely independent chain, or so to say, independent shard, whereas the eventual syncing, it'd be special kind of, so to say, no sync shard, where at the end, instead of rolling up, you just put a snapshot of the last block hash into the main chain, and that's enough. So that kind of shard obviously cannot spend money. You could be just no idempotency guarantee shard. This way, and I don't think Ethereum 2 provides for that. So might as well just run a separate blockchain where eventually, only once in a while, you record the last block hash into the Ethereum. You get the same safety, and the cost is just much
I mean,
lower.
yes, of course. You can run a separate blockchain. You don't even need to run a separate. You don't need to run separate. Multiple nodes. You just need to run one node. You just need one operator.
And sync it up once in a while. Yeah. So
that's exactly what layer 2 does, right? Like ZK rollups, optimistic rollups.
Well, you don't need the rollups. What I'm saying is you don't need the rollups.
Well, you need the syncing but it needs to be
just need simple syncing and no rollups. Yeah, you just need simple syncing and no rollups to guarantee idempotency, which could make it a lot cheaper if you run just baseline.
So it depends on what you want to do with your commercial documents, right? So for example, if you have an invoice, right, and you want to create a loan against that, right, and then you're actually right. So you're tokenizing an invoice, or you're using an order as collateral you're using an invoice as collateral for an order, right? That you want to place, right? So the challenge there is that you need what's called data availability, right?
Yeah.
So you're at the in normal in like with optimistic rollups and or batching, or where you have just a pointer, a URI pointer anchored on chain, right? And where you point back to another blockchain, I'm totally at the mercy of the operator, of the blockchain operator, or operator in general, whether it's 1 or 2 or 3, it doesn't matter, or 200. The advantage for a zero knowledge proof that you anchor is I can actually use that proof as soon as it's confirmed on chain, right? On the public chain, I can use that and utilize it somewhere else. So I can use that for tokenization, or if I get censored by my operator, I can just simply exit that arrangement and transfer it to another operator, right? But that only works if the critical data about the proof of correctness of my commercial documents, right? If that is on chain.
Absolutely.
Not on the, and that needs to be on the public.
Not on a copy, yes.
That doesn't need to, not on a private chain. You're right, I can achieve higher throughput and everything. But the question is, what is being written onto the public chain, right? And what am I intending to do with that particular commercial document? If it's a shipping notice, I don't really care. If it's an order, or if it's an invoice, or if it's an investment contract,
I certainly do care.
Yes.
Right? Then it becomes important that I cannot be censored. Right? It's like if your bank
I fully agree.
closes your account, right? You're SOL, right?
Mm-hmm.
Right? That cannot happen, right? I can't, you know, it's like if you're telling a company, oh, by the way, I can prevent you from using that invoice in factoring or something like that, right? Then they're going to go like, what? Are you kidding me? Right? So it's really important to decide what data is being written on chain, right? And what not, right?
So maybe this is a case to sort of talk to the Ethereum group to create a special provision for sync-only shards.
You don't need that. That's what a rollup is for. A rollup is nothing but a sequence of proofs that are then handed out to the owners, and you can prove at any moment that the asset that the state of your asset is true, is correct, that you haven't double spent it, etc., etc. Right? That's the whole point. In you're reducing your transaction costs, right? Because if I have 1,000 transactions, 1,000 zero-knowledge proofs that I want to write on chain, if I do that as 1,000 transactions, right, that could cost me like $600,000, right?
I fully agree.
Versus if I roll all of them up into one roll up, then it's like 60 cents per transaction, right? It cost me 600, right? It's a factor of 1,000 less. So that's why roll-ups are from a scaling point of view are important.
Yes, what I'm saying is the current implementation of rollups, or basically requirement, not implementation, requirement, is that at the end, this whatever perspired on that shard is transferable elsewhere. Whereas the requirement of the base chain is a lot smaller. You don't really care about transferring everything. You're just recording information. So see, and if you're spending Ethereum, you have 2 shards, and you spend the Ethereum in both shards. That's complicated. So somehow there has to be a sync there. Either you transfer the Ethereum to one shard and spend it there, or somewhere in the middle of everything, do a cross-shard sync with whether it's zero-knowledge sync, doesn't matter. But that's where it's expensive. And for the baseline, you don't care if you write the same proof twice, or in one shard, or in many shards. So the roll-up.
Actually, I do care. Depending on what I want to do with the document. Sorry for interrupting you, but I actually do care. If it's an invoice, I care.
If it's an invoice, you care. But if the invoice has a unique identifier, the zero-knowledge proof of that invoice is unique. Let's say. Let's make it simpler. Are you familiar with Tornado Cash?
Mm-hmm.
Okay, so it's a very simple case. I deposit money into it. It gives me a proof. Mm-hmm. That proof is mine. It's a string, and that's not getting generated on chain. By the way, it's generated in my browser. So I have the proof, and as soon as I submit it, they put a nullifier on the chain. So all the verifier has to do is, if this was on Ethereum 2, they don't care which shard the proof is on and which shard the claim is on.
Mhm.
The
It's
proof is unique.
Yeah,
So
you have
if
an-
it's an
you have an
invoice, same
SPV.
thing. You same invoice can be written twice, but that's a uniquely identified invoice in the ZK proof. So you don't care if you put it in two different charts. And if there's a modifier or nullifier, just like the nullifiers in Tornado Cash, no problem. You can put them twice. Only the first time nullifies it. The second time doesn't matter. And this could make, Ethereum 2 is Ethereum 2 shards are almost an overkill for this kind of a system. So maybe this is a case to propose to the Ethereum group a special kind of shard that is just proof only, no syncing.
Yeah, I mean, you can create any shard that you want, and you can register that shard on the beacon chain, right? No one is preventing you from doing that, right? That's entirely you can write your own execution framework, and that's perfectly fine, and you're syncing to the beacon chain and on at certain times. So the challenge is not the document, is not the invoice. The challenge is if you're let's say you convert you're linking an invoice to an investment contract, and that investment contract is then tokenized, right? So at that moment, right, and then I'm selling the units as a what, it's an ERC 1440 or something like that.
Yeah.
But I'm aggregating, let's say, multiple invoices, let's say 1,000 invoices into that security, right? Which I can. It's not that
No problem.
right. I have the proofs that I do. There's some metadata that I need to write into that, but that's it, right? So I'm not worried about the invoice itself. I'm more worried about the once I've tokenized that commercial document or that set of commercial documents, that then I don't have double spends, and I can choose, right? It's like I can do a very, very simple anchor proof, as you suggest. If I do not intend to tokenize the invoice, right, then I'm perfectly fine, and I don't care if I don't get the data back, right? Then that's perfectly all right, right? I don't need to worry about that. Then I don't even need to generate a ZK snark or anything like that. Then I just need to put an anchor hash that's a URI that points back to some content addressable storage that has a Merkle tree in it, and a Merkle proof, and one of the leaves is the encrypted version of your invoice. That's perfectly fine, right? As long as you don't want to do anything else with it, right? Because you're not putting any PII or any sensitive information on chain, because you're aggregating multiple documents from different business processes into a Merkle tree, and you're using the Merkle proof as an input, right? So your URI on chain points to the Merkle proof, and the Merkle proof has the Merkle proof plus a pointer to where all the leaves are, right? And then you can validate that, and then you have URIs that point to actually where the actual documents are stored. So that's entirely fine. That's entirely doable, and you can use the same concept of validating documents by having smart contracts that have all of these characteristics that need to be validated, address, blah blah. You can make that as complicated as you want, and you're using like an OVM for that, right? And that's perfectly perfectly fine. You're generating the output, and the output goes into as a leaf into the Merkle tree, and you do it, and you anchor it on chain, and you're done. You are absolutely right when it comes to that. If I do not want to use those commercial documents for anything else but that, I'm totally okay. That's perfectly fine. As soon as you want to use a commercial document, that is going to be used for anything that is related to on-chain tokens, then I need that data on-chain. At that moment, I do.
Mm-hmm.
Right?
And so what if they're duplicates?
Huh?
What if they're duplicates of uniquely identifiable things? You don't care.
Well, actually, you do. You cannot use an invoice twice in a financing transaction, right? I can't factor an invoice twice.
Yes. If that copy, if you have a duplicate of the proof, that's not two invoices. It's one invoice.
Yeah, but if I use one invoice twice, if I use the same unique identifier in two different financing, in two different investment contracts, and let's say they were on two different shards, then I have a problem.
But in the baseline, you're not putting out any transactions. In the baseline, you're just putting proofs, right?
Yeah, but you're using that proof in the tokenization, because if you need to, and that's what the tokenization working group is going to do. It is talking about what type of baseline native data needs to go into the smart contract for the token. Does that make sense?
Yes. So there's tokenization where it actually has to be synced. Mm-hmm.
Yes, that is indeed true.
Right. So you need a hybrid system, right?
Mm-hmm.
Where you need to decide whether a specific document is supposed to be tokenized or not. If it's not tokenized, you don't need to jump through all the fancy hoops of a ZK snark and a zero knowledge proof and validation and what have you not. But if you do, right? If you do, then you need to anchor that proof. And you can even make it fairly simple. You can decide whether you want to put a ZK snark proof on chain or whether you want to store it off chain and then just put an anchor hash on chain. Right? If you don't want to run like an optimistic rollup stack and a ZK rollup stack at the same time, you could just run like ZK rollups, and you only put certain ZK proofs into the ZK rollup, and the other one you just store off chain and then anchor it on chain, so you don't need to do the same thing twice.
Okay.
Right. So you're right. In one case, you're putting the actual block with everything on chain. In the other case, you just put the pointer to the block that you have created with the ZK rollups on chain, and the actual block with everything is kept off chain.
Mm-hmm.
Which works too.
So this baseline, what does it contain? It contains not just proofs. It contains tokens as well, which are public.
That's what they not right now, but the value, the big value for organizations, right, is to be able to finance their invoices in real time, right, if they want to, right? So that is enormously valuable if you are talking about cash flow management, right? Or if you imagine you can do you can do now repos without being a bulge bracket player, right? Because overnight paper market, if you're not starting like at a couple of billion, there's like, nah, don't do it. So here now you can do that, right? You can do repurchasing agreements with much smaller quantities, and so sort of like you have a secondary market for repurchasing agreements, and at much lower cost because you're doing everything on chain, right? So you have roll-ups, the transactions cost are significantly lower, et cetera, et cetera.
You can do anything on chain a lot cheaper than with the banks. So
right, exactly. But even if it's a regulated entity, you can show that you're, a repo, right? If you're looking in the US, I'm just talking about the US right now.
Okay.
For a repo, right? A repo, there's the overnight paper market is really individual transaction. There's no market per se. It's not an exchange, right? So what do they do is you're calling someone up and it's like, hey, can I, it's like, can I have like a couple
over the counter? Yeah.
Right. It's over the counter, and there's a third party in there that ensures that the promised the securities as collateral, or the collateral that you put in for the repo is not double spent. Right. So you can do the same thing now that you do, but the third party, which is now often like State Street or Mellon Bank or so forth, you don't need to do that because you have your proofs of non-double spend on chain, right? And so your third party becomes your public chain, and that's just the promised collateral, and then you're aggregating that into the repo, which means you can do this now at much quicker and at much lower cost, right? Because the third party in the middle becomes significantly more. The only thing that they need to do is if State Street were to run a baseline stack, it would be a very cheap solution for low value, quote unquote, lower value repos. Or you could aggregate repos into smaller repos into a larger repo, right? So there's all kinds of new financing options that you all of a sudden open up, right? But again, for that you need to decide what do I want to use for tokenization and on-chain stuff, and what do I need, what do I not need, right? And the key thing is all driven by reducing transaction costs, right? Because again, a ZK rollup, you don't have to put a ZK rollup on chain. Right? The block, you can just put a pointer to the block on chain and keep the rest off chain. Right. The reason why you put the entire block on chain is because you want data.
You need the chain as the proof. Yeah.
You need the chain as a proof. But I can go, left bucket, right bucket. Left bucket is off chain. Right bucket is on chain, and I only anchor the left bucket once in a while on chain. That's it. As you suggested, right? So it's just a hybrid solution.
See, in Ethereum too, basically, if you run your own side chain, the problem is you don't have many miners or stakers. We'll call them stakers now. You don't have enough stakers to actually assure that it's the source of truth. You may modify it if it's just your own private thing or with a few participants. Whereas on Ethereum shard, basically the stakers are randomly chosen to go and verify any block in any shard. They don't even know in advance. So basically, all shards are a source of truth. So the problem with Ethereum is if you run a shard, it's not your own shard. It's for everyone. Anyone can go into that shard. And if it's for anyone, then these proofs will have to occur, and that incurs cost. And that cost is shared among everybody because the stakers, that's what it costs.
Yeah,
Whereas if you
I'm not
able to run a shard.
I'm not disagreeing with you. So it's like if you want, if you have multiple options, right? You can just launch a new shard and make that public, and that's possible, right? To invite stakers in there. That's all good and well. Or you could have it federated and it's just registered on the beacon chain, and you know there are all kinds of different options out there. I'm just saying that for a scalable baseline solution, you don't need ETH2. No,
you don't
necessarily, right? So I'm saying you don't have to wait for ETH2 to have a scalable baseline stack.
You could have ETH1 act as a beacon and your own chain. Yes.
Yeah, or your own single operator, right? If you're doing it, it's just there are trade-offs, right? Is, you know, if you're using ZK rollups and you're putting the rollup on chain, then you're okay with having just one operator because the operator can't do anything. If you keep the blocks off chain and just anchor it through a root hash, then you're relying on the, you know, trustworthiness of your operator, which is fine depending on what you need to do, right? It's like what documents you're baselining.
Now this beacon chain, this baseline is not a two-party system. It could be multi-party, like an auction, right?
Oh, if you want to run it as an overlay network, yeah, sure. I mean, if you wanted to, if you have something that needs consensus somewhere, sure. You know, it's like you can run the baseline stack as a sidechain, right? With a faster consensus algorithm, you use just a proof of authority, and you only have like 5 nodes and 3-second block times, and you're good to go, right? It's again the technique that you want to use based on what use cases you want to be able to map to.
Yeah.
Does
It
make sense?
Yeah, it makes sense. So this is not your problem. The Ethereum 2 needs sort of duplicate agnostic shard feature, which they don't have.
Well, it doesn't really need to. You can use any public shard as your anchor, right?
Well, as long as it's public, it's expensive for you because somebody else is doing expensive stuff on it.
Yeah, but it's well, if you're the nice thing is you can just switch a shard if the shard gets crowded, right? So less crowded.
Fishing for cheap shard. But
yeah.
see there are 64 shards. You can switch shards all you want. They're all going to be more or less as busy as any other, because there'll be transactions that have to be idempotent on each shard.
So Tas, you know, it's like you're very close to that. You know, I see that you'll have shards that are focused on specific use cases because you don't want to have cross shard transactions because they slow things down, right?
Yeah.
Tas. If you want to chime in here. I guess not. Yeah, so I think that there'll be so shards will naturally, in my opinion, will sort themselves into you know, specific purposes, right? Things that are more focused on, I don't know, supply chain. The other one is going to be, or there's shards that are going to be focused more on DeFi. I could very well see that there are different, you know, incarnations of like DAI across different processing centers of DAI across shards. And you know, it's like you have then, you know, we can transfer between shards, but you know, it's I think that is going to be that is what's going to emerge, because you know, if you want to have, you know, you want to have DAI and you want to trade and you want to use DAI and Compound and Uniswap, you don't want to do that cross shard. You want to do that within one shard.
Yeah, it's a big question, but
we'll have
yet to see how Ethereum 2 shows up.
Yeah, I don't really, from a baseline point of view, I don't really care.
You don't
to be
care,
honest.
huh?
I mean, why would you
Oh,
care?
no.
Why
Right,
would you
right.
care?
For now, it's pie in the sky now, so it doesn't really. By the time Ethereum 2 comes, baseline will do improvements too, so nothing to worry about now.
Right. So are there, you know, here we have this key question that we're looking at. So transaction scaling versus transaction cost versus network impact actually versus security. I have that. Right. So how does baseline impact permissionless network throughput and transaction pricing? So I think so I'm really wondering if we're using so if we're talking here in terms of mempool VSM and storage. I think the interesting question here is the mempool from a security point of view. Right, because when you're writing a proof, or when you anchor something on chain, right, you're throwing it into the mempool, right? So the question is, what are all the bad things?
Take advantage of it, yeah, before it's bind.
That can happen there.
Well, that's why it's zero knowledge. So whoever wants to take advantage of it, they can't find anything else about it.
Yeah, but you know the contract, right? Right? Can you censor a baseline contract? Right?
Okay.
The question is that
before it gets to the chain, can a staker do that? Question, huh?
Yeah, it is a node, right? Can I censor or front run baseline transaction?
Censor not. There are many stakers, but front run. You can front run if you know what's in it.
So let's break this out into two. So this is front running. And the other one is censoring, right? Oh wait, wrong one. Censoring.
You don't have to worry about censoring.
Let's just
have it there, yeah.
I just would like to I would just like to
be complete.
Be complete and have it there. Let's talk about, so if it's easy, let's talk about censoring first.
So, really the question is, so really what you need is really a, you need, transaction fee has to be high enough, right?
Yeah. Yeah, that's one thing. Neither of these consensus protocols have fairness in them.
Right.
That's that's something I think it will be revisited in the future, not by baseline, but by blockchains.
So the other question that I'm seeing is, can I collude to censor baseline transaction? Can I collude to censor? Right. So let's say someone says, hey, there's like an investment contract for like $1 billion on the way. Right. So if someone spills the beans,
and then somebody tries
Insider.
to slow down everything, yeah.
I mean, we don't have to answer that necessarily right now, but at least this is the question. I mean, can I collude? So really, so it's a form of preventing transaction based on insider information about large value baseline transactions.
So not all transactions on baseline are zero knowledge.
No, they are. But if I tell you, right? So if you get the zero knowledge proof back, right? And you communicate that out as a transaction is submitted. I mean, there are bots scanning the mempool all the time, right? There was a great story about a Uniswap bug. There were like $12,000 or something like that were locked up, but in order to unlock them, you needed to submit 2 transactions, and they would have to be in the same block. But they couldn't figure out how to do it in the same block and submitted it into 2 separate blocks. And the second transaction of them was front run, and someone swiped the $12,000. So the point is there if I know that a particular proof is in a block, right? Can I extort someone long enough?
Can you slow them down long enough?
Right. So to for example create a competing one. Right.
So you could delay it perhaps, but it's gonna, if it doesn't get in one block, it's gonna, the next block is gonna be mined by a different validator, and you're not gonna know which validator is gonna mine it. So it's gonna be hard to get all the validators to collude to keep it censored for a long period of time, wouldn't it?
Well, it depends on what the MEV is, right? The minor extractable value.
You could end up paying more and more and more fees to get always ahead of that transaction that you want to slow down.
Well, let's say even 50% of the validators are colluding. If you wait a few blocks, you're bound to get your transaction assigned to somebody or mined by somebody who's not colluding.
Right.
Oh, the miners don't have to collude. It's say you want to interfere with the entire baseline. You know something's going to happen in the next minute, and then you just want to throw transactions in a mempool that are ahead of whatever's coming from baseline.
Oh, you could delay it, but I don't think you could prevent it from
You could delay it, yeah.
happening
You could
eventually.
delay it for a long time. Just pay more.
It would be pretty expensive, but yeah. You
Yeah, well, if the baseline transaction is $1 billion transaction, you can end up paying those pennies.
Yeah, well, you might delay it by a few hours, but I don't think you'll stop it.
So if you know what's actually in there, right? So if you're doing trading, right? I mean, you can yeah. So it's like you could front run it, right? So this is
You could delay it so you have enough time to front run it.
right. Yeah, let me do it like this. Let's talk about front running. Right. So you can inject you could inject a transaction that sort of like so what can you do in terms of front running if you know that a transaction is included in a baseline transaction in a block, right? In a block of transactions.
You keep on paying more and more to get ahead of with transactions that just gonna fill up the mempool ahead of that transaction until you get enough time to front run it.
Well, what's the final outcome, right? You want to subvert that. You want to you have two options, right? It's like one is you want to you want to make the transaction meaningless, right? For example, by doing a trade first, right? Or alternatively,
What kind of a trade could you do that makes it meaningless?
so for example, let's say you want to sell an asset-backed security, right? And I see that, and I have insider information. So this is like insider trading.
Yeah.
Right. So I have insider information about that baseline transaction, which could be a tokenization transaction.
Okay. So yeah, that makes sense. So when you're talking about like front running a purchase order, that probably doesn't make sense. But if you're talking about tokenizing stuff, and
yeah, exactly.
If the asset is non-fungible, certainly you can grab it before the other party can.
Yeah, the tokenization. Right. I mean, the challenge is like you would need to. I mean, if it's just a zero knowledge proof or it's just a pointer, you just need to have specific information. And then what can you do? You could submit. What can you do? You could submit an alternate block. I think that's pretty much the only thing you can do, no? In terms of front running, you can't really inject a new transaction, right?
Well, somebody could like if you're trying to purchase a token, somebody else could come along and purchase a token with a higher gas fee.
Yes, but that is already when you already have a
baseline token, so to speak.
Yeah.
Let's just go concrete. Suppose eBay auction and eBay is on baseline. Auction is ending now, and you want to buy that item cheaper. So you bid, and then you put stuff in the mempool ahead of the rest of the people.
Yep, you can do that.
So they cannot catch the deadline of the auction, and the auction finishes, you get a better price.
Yep.
Yes, but that is already out. That is sort of like already that is like, so you have turned your baseline asset into a token, and then you're putting it into like a DeFi protocol, like an auction protocol, right? So that's the auction itself. I'm thinking about the actual baselining transaction. Right? Is there if I know that there's a very large tokenization transaction, right? So there's an investment contract being created. Is there a way to front run it?
If the two parties already have a consent, there's nothing you can do. But if you're competing with other parties, you can always front run, slow the others down.
Yeah. But that's really, I mean, front running is really injecting yourself, getting yourself ahead of the queue, right? And doing that. I think what you could do is spam the it would be spamming the baseline contract. Do you know what I mean?
Just to delay it.
Yeah.
Yeah, you could delay it.
Right. So that would be, I think this would be like really it would be more, there would be more spamming, right?
Mm-hmm.
But that would that can be avoided if this is if it's permissioned.
Mm-hmm.
Right. I mean, you could in principle, like, yeah, but then you would have to spam the entire net. You would have to DDoS the entire network, right?
Mm-hmm.
Alternatively, is spamming the entire network, right? But that's expensive,
Mm-hmm.
right? That would probably be cost prohibitive, right?
If you want to keep it up for a long time, yeah.
I mean, everybody and their cousin would start screaming.
Mm-hmm.
Now the question is, it's like it depends on if you know that there's a lot of value at risk, and if it's time sensitive, then that could be an option. But otherwise, I don't think it's relevant.
Yeah, and it would be hard to know when a transaction is about to be sent to the network. As well.
Yeah, you would have to have insider information. So I think yeah. So I think that's done. if permission, and you could also do staking.
Oh, right. Put up a bond.
Right, it's like bonding baseline operators. So those are, I think, the most effective. So you can say, well, I can pretend to be baseline operator, and then I'm like spamming the hell out of the contract, right?
Mm-hmm.
If I know, because I have permission, I have write rights.
How do you prove that somebody's spamming and should be punished?
So you can do that by, for example, I could actually show you a piece of code that I wrote. You can require that, for example, every operator is only allowed one transaction per block.
Mm-hmm.
So you can check. So if the first transaction comes in and is processed, right? The next one that comes in, if it comes from the same operator, right? And you just simply check. So you increase the counter, right, internally, right? But the block number is still the same.
You're talking about layer 1 blocks or layer 2 blocks?
Layer 1 blocks.
Okay. Right.
So the block number is still the same. So if you just check, is this number higher? Was the message.sender the same? Mm-hmm. And if the block number is the same, you immediately slash the entire bond.
Okay.
Right, and
you can have a third party helping you.
Huh?
That doesn't help you. You can have a third malicious party helping you.
Yeah,
Say,
but that one would have to be. You would have to stake. You would have to bond that third party, too. And if you're saying, well, baseline operators are high value operators, and you're requiring like, I don't know, like 40 or 50 ETH or 100 ETH to be staked, that gets expensive pretty quickly. You would have to be registered as a baseline operator, and then you have to
on a public blockchain. But on a public blockchain, only the attempt counts. So it doesn't matter if they fail. Say in the smart contract function, you have some kind of a guard that guards that only a member calls it. Who cares? A malicious party can just go in and spam it with calls that fail, thus slowing the whole thing down, and you don't even know who they are.
Right, but they then still have to pay I mean that's spamming the entire network, right? It's not just a contract; it's just spamming the entire network.
Yeah.
Right? You're at that point. It's like you're spamming. You're spamming the entire network, and if you, and it's going to do, and if you have the code as an assert, not as a require, not as an assert, or you have it as a revert, then it actually costs you a lot of money.
Mm-hmm.
Right, because then the entire it's not like it's going to get refunded. So I think the combination of sort of like permissioned writers and bonds would make it sufficiently, would only leave like trying to DDoS the entire system to get to slow down a transaction, which could be worth it if the transaction is super valuable. Right, but in a high price environment, DDoSing Ethereum when the transaction fee was like 10 cents a transaction versus now where you could easily get like $20, $30, $40, $50.
Yeah,
the
and we
transaction.
just don't see it happening really.
Yeah. You don't see that happening. It's just not worth it, because it's just the value is just in slowing things down or preventing it from happening.
Mhm.
Since there's no direct on-chain value unless you've tokenized something, it's not really something you can really influence.
Yep.
So
I think that's
So you're talking about this tokenizing and dealing with tokenized assets on layer 1, but should the layer 2 solution for baseline also be able to handle tokenization and tokenized transactions of tokenized assets?
Mhm.
So does that imply that the layer 2 solution should support general computation?
Mhm.
Okay.
So I mean, this is here virtual state machine. So one of the requirements there is for sure is that it supports general computation.
Okay.
Right. Which could either be in zero knowledge or not.
Mhm.
Right. I mean, so the question is, can you see the so what are the so the interesting question is about visibility of data.
Mhm.
Right. So can I what can I see? Right. What can I or what can the operator see?
Mhm.
Right. Does the operator, is it okay? So the key question here, I think, is, can the operator see like input data? Right. Or is the operator allowed to see the data in the clear?
The tokenized transactions.
Yeah, or any transaction, right?
Yeah. Well, the zero knowledge stuff they won't, but it's transactions with tokens they could see, unless they're done with something like Aztec.
Yes, exactly.
Uh-huh.
Right. So then if we have that, if the answer is no, so if the answer is no, then we say no. Then we have, what do we have? Then we need CKP for non-token transactions.
Mm-hmm.
And we need and we need Aztec type transactions.
Mm-hmm. And
or tokens.
I'm wondering if that's like a short-term requirement, or if it could be yes for now, but no in a couple of years when this stuff is more mature. Because like Aztec is great, but it's not completely ready for prime time yet, I think.
Yeah. So if the so here's the yeah. So here's the question. So let's explore the yes a little bit, right?
Mm-hmm.
I would like to understand the yes a bit more. So yes, what options? So we're, if everything is no, then we're stuck here. If the answer is yes, then can we have what options do we have here? We would have optimistic rollups, right?
You have rollups, although my instinct is that rollups don't provide the scalability needed for something like baseline, and that something with off-chain data might be better because it's more scalable. But rollups are an option.
Optimistic rollups. Yeah. Otherwise, it's just it would just again a question is So what?
You've got optimistic rollups, you've got ZK rollups, and then you've got hybrid things like Arbitrum.
Yeah. But that is really that's a side chain, really.
It's kind of a side chain, but it falls back to a rollup if anything goes wrong, and it is secured by layer 1. So I don't think of it really as a side chain. It's sidechain-esque. But because a true sidechain is not secured by layer 1, but I believe Arbitrum is.
Right. So, but the real challenge. So let's actually let's do this here. Let's talk here about tokens and non-token transactions. I would like to break that out. I think that's better.
Yeah, good point. Yeah, because if you're talking about pure token transactions, then you have more options like fuel.
Right. So let's talk about the non-token transactions first. So what do we have? We could have this. And then we could also have, what else could we have? Yeah, we could have, well, I mean, if you can see the data, why use ZK rollups, right?
True.
Except for the tokens, maybe, right? So it's a question of
I mean,
it's really like sidechain type things.
You don't have the exit delay problem with ZK rollups.
Yes, that's very true, right? So here it's like here you need really here you need ZK rollups.
For tokens?
Yeah.
If they're fungible tokens, so are the tokens fungible or not fungible? I guess they're not fungible, right?
Depends. They could be fungible.
If you're talking about fungible tokens, then you have options like Fuel, which is a rollup, but it's more scalable than something like Optimism. They use UTXOs.
Okay, yes. If you use UTXO, but you have the data availability problem then still.
No, they post everything on layer 1, but they use UTXOs internally. So they get more throughput than.
But don't you? Yeah, but if you use UTXO, then it's like Bitcoin, right? So you just need to.
Within the layer 2, it is, but it's still a rollup in that all the transaction data is posted to layer 1.
Right, but you need to be able to follow the UTX. So you need to from layer 1 block to layer 1 block where the rollup is written in. I need to be able to reconstruct. I have to be able to go back to the Genesis block.
Yeah, I think they have some way of doing that. I'm not sure how it works.
Okay. So okay, so let's just say ZK, and then the alternate, another one is like UTXO
rollup.
Okay, why is this not? So now the question is, so that really, so what we discussed before we came is like you could do just ZK rollups and then decide whether you want to post the data on chain or just keep everything off chain and just post an anchor.
Yeah, I like having, you're talking about Volition or what do they call it? ZK Sync, ZK Porter, right? I think they're both.
Yeah,
like
ZK, yeah. So ZK Sync posts everything, all the transactions, but there is the option if you use the porter, then you can you don't have to post all the data. You just have that in a you just have that off chain in the network on a shard, and then you just anchor that on L1.
Yeah, I think that's pretty interesting because it's way more scalable than a standard rollup, and data availability doesn't seem like an unsolvable problem in the baseline space.
Yeah, I think that there's an interesting option of doing. Let me see what. Hold on, no, it's not what I wanted. It's like.
I mean, one option is any company that is concerned about data availability can run their own node and store all the data.
Yes, so it's a hybrid. It's a ZK. It's a really ZK rollup hybrid where you have.
I think the term that Starkware gave for this is volition.
Yeah, volition. Okay.
I don't know if everybody's buying into that name, but that's what they.
Yeah, whatever. It's like it's a house. So this is this is like ZK roll up on chain, posted on chain for tokens, and then the other one here is ZK rollups, but only anchor hash on
Validium
chain.
is what you mean, right?
Huh?
Validium is basically what that is, right? Yeah.
Yeah, or yeah, it's you just keep the block gets stored rather than the block gets stored off chain, and you have a pointer.
Yeah, just the hash, and then
that,
the data's off
hash.
chain. Yeah, right.
Yeah, and the data is off chain. Otherwise, it's just like ZK Sync or any other ZK rollup where you just post the entire thing on chain. Right. So this would be like, and this is really for tokens and this is like, this is a hash on chain for non-token transactions.
So I would think that if that layer 2 solution only allows a single operator to run the layer 2 and to store the data, then that would be a problem. But if anybody who wants to can participate in storing the data, then that might be a pretty good solution.
Yeah. So this is around data availability here. Now we're talking about data availability. And not and for here, right? For here, for this one here. So this requires, there are two options, right? So you have network storage operators. Not
storage
necessarily
operators.
process.
And they could be more than storage operators. They could be validators too, or well,
Yeah.
actually in ZK maybe not, because you have to have a prover, and only one prover is going to be running. But
Yeah, I think this is more like IPFS type thing.
yeah. So like Arbitrum is an example. So in Arbitrum, you can have any number of I forget what term they use, but operators essentially, and any operator can participate in validating and mining blocks and also making the data available.
Yeah. So this
So any
is
company that's concerned about that can just run their own node, and then they don't have to worry.
right. So it's at minimum is a storage operator, could be full validator.
Right.
Validator, validator or full operator. Right, which you I mean you need a validator here too anyway.
Yeah.
Right. I mean you post it and then someone needs to validate the block.
Of course. Yeah.
Right.
And generate the proof. And generate a proof.
No, the proof is done by the operator. No, it's it's like when you the operator posts the block with the proofs, and then someone needs to finalize the block by checking the proof, by calling the validation function.
Isn't that done on layer 1 by the smart contract on layer 1?
No, that's a yes, but someone else needs to call it. So if no one calls
right.
then it gets rolled rolled back.
Right. It's got to be called.
Right. Right. So you have to call some third party needs to call the validation method in your rollup contract.
Right. I mean, it could be the same person who's generating the proofs, but it doesn't have to be.
It doesn't have to be. No. It's just someone needs to call it within a certain number of blocks. Otherwise, that block is going to get rolled back. And you can submit multiple blocks, right? So there's a fail-safe in there that, you know, if you have more than, I don't know, 10 or 12 unconfirmed blocks, then you're starting to roll back. Right? Then you're rolling the old ones. You're taking the old ones out and then, you know, updating the new ones. So you're rolling it back from the end. The oldest ones get kicked out.
Yeah.
Right. At least that's how ZK sync works. And I'm sure loopring too. So yeah. So that's that. But I think I like that concept of because it preserves privacy.
Yes.
Right. And the and so the key question is, so there's obviously here for tokens, there is one thing though, this is not 100% anonymous, right? That's clear, right?
Right. I mean, yeah, definitely. It's even with an off-chain data, it's not 100% anonymous, but it's more anonymous.
Yeah. So, but it's not fully anonymous, but can be private.
Yes.
Right, because you have right. So this is you know, you can for example, you can and that really depends on the mechanics of the tokenization. Right. So for example, if a if your user, you know, tells the operator, okay, tokenize this invoice and make this Ethereum address the owner, right? Then there is a priori no connection even between and you know, between anything in the baseline. So nothing. There's no correlatability directly between of identities, right? So it can be private, and that is, wait a second, that is dependent on, right? So that is dependent on, right? So that is dependent on, right? So that is, wait a second, that is dependent on, right? So that is, wait a second, that is dependent on, right? So that is, wait a second, that is dependent on, right? So that is, wait a second, that is dependent on, right? So that is, wait a second, that is dependent on, right? So that is, wait a second, that is dependent on, right? So that is, wait a second, that is dependent on, right? So that is, wait a second, that is dependent on, right? So that is, wait a second, that is dependent on, right? So that is, wait a second, that is dependent on, right? So that is, wait a second, that is dependent on, right? So that is, wait a second, that is dependent on, right? So that is, wait a second, that is dependent on, right? So that is, wait a second, that is dependent on, right? So that is, wait a second, that is dependent on, right? So that is, wait a second, that is dependent on, right? So that is, wait a second, that is dependent on, Depends on level of privacy. C depends on tokenization process.
So that's a good one. But I think we have sort of like a leading candidate, right? Because you can get like pretty high throughput with CK rollups, even with generalized ones already.
Yeah. Well, if you're talking about ZK rollups with on-chain data, I mean the big asterisk next to the numbers that they always publish is that, let's say they assume that they say you can get 3,000 transactions per second. That's assuming that they're utilizing 100% of layer 1 capacity. So that's
well, that's 10 trends. That's, well, it depends on if you, so with Ethereum, right? If you at a 15-second block time and 300 TPS, you can put 4,500 transactions in a block.
Yeah, we're getting about 30 or 40 transactions per second, right?
Yeah, so no,
And
well, like
might,
300.
the rollup
does about 300.
Yeah, 300, or I've heard even higher numbers like
Yeah.
3,000. But let's say it's between 300 and 3,000, 10x to 100x. But that's assuming that you're using all of layer 1 capacity, which is totally unrealistic. If you only have 5% of layer 1 capacity, then you're only getting 5% of that on layer 2 on the rollup.
But you're because yeah, so the gas cost for, but it's like 2.2 megabytes of, so 4,500 transactions, right? In a block is about 2.2 megabytes, and that's less than the block gas limit, right?
I think block sizes are currently running around 50 kilobytes, although they can be larger if they're consisting of mostly rollup data.
Yeah, because it's just call data.
It's
not
right.
transaction, right? So it's all call data.
Well, it's 2 gas per. Is it 2 gas per byte?
Yeah.
2 gas per byte. No, so it's more than that. It's 16 gas per byte.
16 gas per byte.
Yeah, it's 16 gas per byte.
Then it's
so it's about a megabyte, I think.
Yeah.
Yeah. Okay.
Yeah, it's about a megabyte. So that's about half. So it's about 2,200 transactions in a block.
Right, but that's assuming that you're using
up the entire block.
You're the only thing on layer 1, which is not realistic.
Right, that's true. Well, it depends on if you pay enough.
Yeah. Nobody's going to be very happy with baseline if they take up all of layer 1. But the nice thing about the off-chain data stuff is it scales exponentially, so you can run many side chains or plasma chains or Arbitrum chains or Validium chains as you want, and run them in parallel, and they don't take up all of layer 1. And you can, so it's much higher scalability if you run them multiple chains in parallel.
Yeah, it's really just tokenization transaction that where you need the data on chain.
Right.
So literally, you can say everything is all documents that are not slated to be tokenized can be done all.
Actually, do they even need to be on layer 1 so they would need to be on layer 1 if they're going to interact with DeFi or something that's not baseline. But if it's just doing baseline stuff to other baseline stuff, do they even need to be on a layer 1?
You only need an anchor hash.
Yeah. So they could stay, all the tokens could stay on layer 2 unless they need to interact with something that's outside of the baseline ecosystem.
Yeah, you could, yeah, if you could do it. Yeah, you could totally create a token that only lives on in baseline, in the in the baseline ecosystem, but then you need to agree upon which proof system you're using.
Which layer 2? Yeah.
Right. So exactly which layer 2. So that's an interesting, yeah. So that's actually a point here. Let me add that here. Running out of space. That's a good sign. So that is really could be actually we can put that here, and we could say that could create only baseline token not on L1 and only usable in
Mm-hmm.
Right, and that point you're just anchoring the fact that it exists on
Layer 1.
On layer 1.
Yeah. Could create only, the third word should be only, right?
Could create, no, n baseline token. A baseline token.
Okay.
Not on L1 and only usable in baseline ecosystem.
Yes.
Right.
Yeah, and like maybe there could even be sort of a single baseline layer 2 that all of the baseline tokens live on that everybody can agree on.
Yeah, so that would probably require agreement on proof system. ZK P's are used, or we have live on sidechain, right?
Sidechain or some other, I mean, like even a Validium type thing, perhaps.
Yeah. So I'm because it's enterprise. I'm saying like Onyx.
I'm not familiar with Onyx.
Onyx. What I'm saying. That's sorry. That's
Arbitrum?
No. I'm sorry. This is not. This is JPM coin.
Oh. Okay.
Right. So because you're now talking about enterprise world.
Yeah.
Right. And you're not talking DeFi anymore.
That's true.
Right. So it becomes a real question. So but that's I mean that's already that's already really good. But that's so yeah, and you could actually do both. Right. So you could have tokens that are just ZKP based, and tokens that are just then living on a side chain.
That's true. Mm-hmm.
Right.
You wouldn't want it to be too fragmented, but you could have a couple.
No, but it really depends on what you want to use. So if you, let's say you want to have a stable coin on like, you want to have JP Morgan coin, and you want to have JP Morgan coin, right? And then you're putting up collateral to get JP Morgan coin.
Oh, okay, yeah.
And that could be baseline, right? Based on a baseline token.
That's true, yeah.
Right. So, or it could be, and then you can wrap the baseline. You can issue the baseline token there, and then you can exchange it for JP Morgan coin.
Mm-hmm.
Right.
Yeah.
So that could be a viable enterprise token ecosystem there.
Mm-hmm.
So that's great. Yeah. Okay.
Shall we take a 15-minute break? I've neither eaten nor gone to the bathroom in like 4
break.
hours or something like that. So you guys can continue on, and again you can continue to fill in this document, because it's the link is available, and I'm just going to stop sharing and put myself on mute, and I'll be back in like at 4:15 at 4:30 Eastern, 1:30 Pacific.
Okay, I've got another meeting coming up, so I'll maybe in or out, but
Okay,
this is
cool.
great. Cool.
No,
thanks.
this is great. Okay, cheers. Bye.
Yeah, okay. Thank you.
I'll be
Bye.
back. 15 minutes.
Okay, bye-bye.
Hi, Andreas. Andreas. Hi.
Hey guys.
It would help if I put my thing in. My earpiece. It's like, why is he so faint? Hold on, let me go back. A second. Too many tabs. All right. The other question that we had, I think we've beaten that to death, is determinism versus parallelism. How to ensure correct state transitions in a parallel processing environment. And we had started to discuss this a little bit earlier.
Yeah, so you just have to avoid parallelizing transactions between a given set of entities, right? Or between any pair of entities.
Yeah, so we have the VSM.
What's VSM?
Pool, virtual state machine.
Oh, okay.
Storage. I think that's not really that big of a deal here. So I think, do we need to worry about anything in particular? Let's start with I think there's determinism is really not relevant for the middleware piece because you're just, I mean, it's relevant in terms of message completeness and everything, but that is not something that we need to worry about.
Mm-hmm.
That's sort of like, I think this is really on the messaging side. Messaging, and that's really here. It's really the message protocol.
Mm-hmm.
It's to ensure proper sequencing completeness. Right. I think that's the key here. I'm using like something like Kafka or RabbitMQ or something like that.
Mm-hmm.
All right, so you have to have you have to have message numbering and so forth, but those are like all solved for problems. The question is, I think there's nothing on the interfaces and application side. This is really an A in terms of determinism. It's really here on the processing side. Is there anything that we need to worry about in the mempool, right?
Well, do those things need to be considered separately, or can that whole layer 2 instance be thought of as a unit and not be broken down further?
I think it's helpful to break it down further to really identify where we need to worry about determinism versus parallelism.
Okay, mempool
right?
seems like the main place, right?
Yes. It's two places. So one here is what do we? So we need. So the question is, do we need anything? Do we need deterministic deterministic UUIDs, right?
For each
Or
transaction.
yeah, or UIDs, yeah. Per transaction, right?
Then who assigns those?
Right. So I think there's so one option would be so we really need to distinguish. Actually, we need to distinguish here two cases, right? One case is if you have a network.
Yeah, versus single operator.
Versus single operator, right? So I think so from a single, I think the single operator is easier, right? Because you don't need to synchronize anything.
Do they need to be both deterministic and predictable, or just deterministic?
What do you mean with predictable?
Well, like, do you need to know that transaction A will be processed before transaction B, or do you just need to know that nobody will be able to mess with your order?
So no, so you need an ordering, and within that ordering, you also need to ensure that A happens before B.
Okay, so predictability.
Predictability. So you need something like a nonce.
Yep.
So so I think for the mempool, you only need ordering.
Mm-hmm.
Not, I think the or question is, do you want to put that? I think you just need ordering. The VSM will then grab a batch and then process. So here's an interesting question, right? If you care about A before B, right? Mm-hmm. Do you need to worry about latency issues that could sort of like make transaction B that should happen after A come into the mempool before A? And then I'm grabbing B, not knowing A, and then I fail B because the nonce is not right.
Mm-hmm. That sounds difficult unless if you don't have a single operator.
Right. So do we need do we need a workflow identifier?
Do
you know what I mean?
Workflow identifier.
An ID for a workflow.
That all the steps are. Oh, okay. So all the steps are part of the same workflow.
Yes.
And across workflows, you don't really care about ordering.
Right. I don't care about. Yeah, I don't care about order.
Mm-hmm. That might make sense.
So, do we need? So I think the answer to that is yes.
Sounds like it.
I think the answer to that is yes, because we need to preserve the logical ordering per workflow.
Mm-hmm. Is there any situation where you might care about ordering cross workflows if the workflows are between the same entities? Like purchase order A should come before purchase order B?
Well, that is the, yeah, for sure, because that is implied by. So we need. So that is why we need really what we need so the is here is we need a nonce. You need unique counter, right?
Yeah.
Counter per process, per workflow.
Per workflow, yeah.
Right, workflow.
So workflows need to be unique, and then the steps within a workflow need to be uniquely ordered. Okay, yeah.
Right, because otherwise I don't see how else you can.
Is it sufficient to just have one ordering, or do there need to be two levers of ordering?
What do you mean, two layers of
well, you've got ordering of workflows and then ordering of steps within a workflow. Could that be collapsed into one layer of ordering?
So I think you have, so you're thinking of, I think each document kicks off its own workflow. Oh, what you need a workflow, and you need a workflow instance. Do you know what I mean? So you have an MSA, let's say that has ID 1, and then you have then you generate a purchase order off of that MSA, and that has ID 1.
Okay.
Right. So it's and that is sort of like purchase. That's sort of like in the procure to pay workflow, which has ID 1, 2. Right. But then you need to identify which are the if you have different documents, different purchase orders, they're different.
Yeah. Which is the workflow? Is workflow the second layer?
So there's a workflow ID, and then there's an instance of that workflow, because the workflow is sort of like you need the MSA, then you have to have an order, then you have to have an order acknowledgement, then you have to have a shipping notice, then you have to have a receipt.
Oh, okay. So workflow is like a template or a list of steps.
Exactly.
Okay.
Right. So you need and then for that particular workflow you have an instance, right? So it's like 1, 2, 3 -1, 1, 2, 3 -2.
Okay. And then you have steps.
Right. So actually here we need to have the per workflow instance, which means we need actually we need to all we also need to have we need to have a workflow instance ID.
Yeah, and on the left you need a workflow counter, unique counter per workflow instance.
I'm sorry, what?
On the left side, you have unique counter per workflow instance, right?
Yeah.
That's per
Yes.
instance.
Yeah. Yes.
So you still have two layers of ordering though. You have workflow instance ordering, and then you have transaction or workflow step ordering within that. Is there any way to collapse that into one ordering?
I don't think so, because again, it becomes so. So you need to apply. So it's important. So the instance ordering is also important,
okay.
right? Because if you have kicked off instance 1 and then instance 2, right? It's important to know that instance 1 was really supposed to be kicked off as instance 1, not as instance 2.
Okay.
So we have a question: is who assigns those? Right. So really the one of the key question is who assigns the identifiers? Who assigns identifiers? Well, that's the key question here. Wait a second. This one. So yeah, so who assigns identifiers? Good question.
A single operator, you can have the operator generate them, I suppose, but if it's a network, it's still difficult.
You know what? I would have the user assign, except for the nuns. No, even the oh, you know what? The user should just generate that, right? Because the nonce is in Ethereum is also user generated.
Okay, just a random number.
No, not a random number. It's like a counter.
Oh, the counter. Okay.
Right. So the nonce in the Ethereum account, it starts with 0.
Yeah.
Right. So and the validity check is that you're submitting a transaction with a nonce 1.
Yeah.
And then 2. And if you're submitting another transaction with a nonce 1, that transaction gets rejected.
Right.
So the client doesn't assign the nonces. It just validates the integrity or the consistency.
So if two parties are transacting, can you assume that they both know what the next nonce should be? I guess they should, right?
Yes. So really, here is the hold on. It's not. I think the workflow initiator should assign the identifiers.
Just to jump in, isn't that already guaranteed by having a workflow instance, or must be incorporated there?
You can have multiple steps in a workflow instance.
Yeah, sure.
Right. So in each workflow, you need a counter.
Yeah, but that if workflow has a meaning, then that means in the instance of the workflow, all the steps are inherited already.
What do you mean?
On the right hand, we need to preserve the logical ordering per workflow instance. So, so I have instance 0 or 1 of the workflow.
Mm-hmm.
The workflow itself isn't nothing arbitrary, but is a defined logic of steps, isn't it?
Yeah. So the workflow is sort of like is a template, right?
Yeah, and
then
within the template there is defined shipping can't happen before ordering, for example.
Correct.
Placing an order. So the identified steps or the steps which need to be executed only after A is already identified in the workflow.
Mm.
Or what do you mean? Who assigns identifiers?
So, so what identifiers do we have? We have the identifier of the workflow itself. That's a unique identifier, right?
Yeah, that's like a smart contract.
Yeah, whatever. It's a string. It's a unique string.
Yeah,
it's a GUID.
Yeah.
And then derived from that, there's an instance of that workflow.
Yeah.
And so and then there are so for example, there's a base document, there's a base state, right? And that base state for 2 different instances could be different. Right. So if I have price discounts based on volume that I've ordered, I have different pricing on 2 POs, right? So it's important which PO comes first, right? So what's important?
Yeah.
Right.
Yeah,
so
got it. Yeah.
Right. And then within the instance itself, I could have multiple shipping notices.
Yeah.
Right. Or you know, or I could have multiple receipts, and I can have returns and things like that. So, but they happen within one instance. So I need a counter of those because the number of steps is not necessarily fixed, right? Is these steps occur, but I have no constraint necessarily on how many times they can occur, right? So I need, for each instance, I need a deterministic counter.
Yes, sure. Yeah, got it. Right. Yeah.
Right. Identifiers, nonsense. Right. So and especially if they share a common state. So there's so here's a question. How are we going to represent 2 instances that are based off of a particular document that has the same document, 2 different states? So that's the example of, you know, PO1, PO2. PO1 assumes a certain state of the MSA, and PO2 also assumes a certain state of the MSA. So now we can make a hard requirement and say that that only when you submit your PO, you need to read the latest state off of baseline, because then you know exactly what's the right nonce, which is the work, you know, for the which instance, and what's the right state of a document, because the underlying document of a workflow could have changed state, right? The MSA could have changed state because of the commercial transactions that have happened.
Can you be sure that the state won't change between the time you read it and the time you submit your transaction?
That's exactly that is the problem, right? Which I mean, you can I mean, you could solve it by saying by introducing a bottleneck and saying every transaction needs to come from the same account, from the same identity, and that identity is responsible for ordering.
Mm-hmm.
Right? So it's like it needs to make the consistency check and say, well, no, this PO1 actually really happened before PO2. So you need to process PO1 before PO2.
Mm. Is that something that could be negotiated between the parties rather than having a third party arbitrate it?
No, it's not arbitrated. It's if you instantiate the workflow, you're sort of like setting the I mean, you agree on the rules and everything and on the initial state.
Mm-hmm.
I'm just thinking, so what? So how can we? So we can just do a hard. We can just do a hard a hard fail. In the VSM, if, for example, you submit 2 transactions with the same nonce,
Mm-hmm.
and then you're just picking the one that has the earlier timestamp as the or the one that's processed first, whether that's right or wrong.
Yeah.
Right. Because you have advanced the state deterministically, right? Now the interesting thing is, if you're but let's stick with that example of PO1 and PO2 where the pricing is dependent on certain things. So if you know about the state of the MSA, then you're applying the right discounts based on the state. That means you need to assume that PO1 has happened already. If you submit the ones with the wrong pricing, right? So for example, you have you have PO1 and PO2, and both are submitted assuming that no discount has been hit yet, right? And then they're processed one after the other, right? And at that point, it really doesn't matter whether one happens before 2, because one will have the correct pricing and the other one will not, because discounts kick in, right? At that point, you would say, no, sorry, that PO is wrong because you haven't applied the right discounts, right? So one would be rejected and say, no, you gotta
yeah,
gotta redo, right? Mm-hmm. So it would be rejected because both have assumed the same state,
mm-hmm.
right, of the underlying document from which they derive, and then it's just,
so it gets retried.
Yeah, so then it's a retry. So it would actually be rejected for 2 reasons, right? And you have to list all of them. Number 1 would be would be the nonce, and the other one would be the state validation.
Mm-hmm.
Right? Even though you could just say, you know what? Just thinking. Yeah, it really doesn't it really doesn't matter. So if both have nonce 3, let's say it's 3, and both have the same assumption. So one will be processed successfully, and the second one has 2 failure sources. One is the nonce, right? Because it should be 4 instead of 3. And the other one is because now the state has changed, and there's no and the state variables for that given into the program no longer match. They're wrong. So that is that's fine. The other failure is what other, do we have another scenario where if you have 1 and 2, and 2 depends on the state of 1, but 2 comes in, then you would reject it because the nonce is wrong, because you submitted it with 4, but you're expecting 3, right? And then you're set, you skip 1, so you should retry. And otherwise, I think that's fine.
Mm-hmm.
So if you know the workflow ID, if you know the workflow instance, and you have a nonce, then that's fine.
Sounds like it.
Okay.
So what you need to submit really here is okay. Yeah, I think that's it, and it's all assigned by the identity that starts it, that kicks it off, because everything else is then passed on from party A to party B. So then party B knows exactly what the workflow ID is, what the workflow instance is, and what the nonce is.
Mm-hmm. So the operator doesn't have to do anything special here.
No, the operator only has to check the operator only needs to check the consistency of or the validity of the workflow ID, the workflow instance ID, and the nonce.
Does it even need to know about those things? So like, does this need to be a customized layer 2 that understands baseline, or can it be, you know, like out of the box? Optimism, Arbitrum, ZK, whatever, that without customizing it to understand the baseline protocol?
So I think it does not need to know the workflow ID, but it needs to know the workflow the workflow instance. So it needs to have an account, because that's the state. Right, so you need the state somewhere, right? So and each instance is represented by a state, right? So you need the concept of state within your operator somewhere, right? And that's most easily done, and is currently done in, I think, in any layer 2 with through an account.
An account or a smart contract that's deployed on it.
Well, the account is off-chain.
Yeah, right. Well, so I mean, an account, can an account have an arbitrary amount of state associated with it?
No, 1.
Okay.
So each workflow instance will be its own account.
Ah. Okay.
Right, because and once it's complete, right?
how much state do you need to store per workflow instance?
Just what the current
Just
what
the
the
nodes.
current.
Okay.
No. It's just like with Ethereum, right? So Ethereum has the world state is the hash of the account.
Yeah.
Right? That contributes to the so and the account of a smart contract has two additional fields to it, right? It has the storage root hash, and it has the contract hash.
Mm-hmm.
Right? And so similar here, you would have the contract hash of the contract that underlies the processing, and then you have the actual storage state, the actual state of the document, right? Or of the sequence of documents, right? And that way you're and then you hash the whole thing, and that becomes sort of like your hash that goes into the state, into the overall state root, into the overall state Merkle tree.
Okay, so it sounds like you could do this on an out-of-the-box layer 2 that supports general computation.
Yeah, you need a more customized account structure.
So let me show you something. Where do I have that here? Load, come on. So you would need so like for ZK Sync, you need something like this. It's based on ZK Sync. So there are two layers of and this is you would need sort of like the pub key, so you can have multiple owners. So each owner, each one has their own account. Right, so there are the owner accounts; those are the individuals, and then you have the account. So that's the first layer of the Merkle tree. That's like the balance in the balance leaves in the for ZK Sync, and then you have the actual account. Right, and that has a slightly different structure, but it has owner hash, number of owners, conditions, how many owners need to sign off. In nuns, you have a balance for a specific, if that thing represents a specific tokenization, and here you have the account state root, which consists of all the data aggregated up from the actually it's just the latest it's just the state root for all the transactions that happened off chain on it. That's it. And that is then goes as an element into the overall Merkle tree that has the state root that is then used for that's a public input data into your ZK proof. Right. Yeah, so it's very similar to like a ZK Sync Merkle tree structure, but it's not quite the same. It needs some modifications. So you can't do it directly out of the box. It's just not possible.
Not a huge change, but it is an important change.
Yes, it's an important change. It's not terrible, but it's an important change.
Yeah. Okay.
right? Because this allows you, it's like this allows you to then, have, so if this is a workflow instance, right, then you can see how this evolves, and we can add additional, so like the account ID could be the hash of the whole thing, or it could be the workflow instance ID, right?
Okay.
Okay.
Cool. I've got another meeting I'm gonna have to jump out for, but this is exciting to see.
Cool.
All right. Good luck.
All right.
See you.
Cheers. Jörg, ich spring mal schnell rüber zum Tokenization und guck mal, wie es da läuft.
Ja, Andreas, lass mal. Ich habe jetzt derartig viel gelernt. Das war total klasse.
Ja, super. Nee, ich komme auf jeden Fall wieder. Also
nein,
geht morgen auch weiter.
Eben, lass es uns morgen weitermachen. Es ist schon es ist fast 11:30 hier.
Ja, nee, lass du mal. Wir machen das morgen. Wir machen das morgen weiter.
Das ist, man lernt mehr als bei allen anderen. So, lass uns das morgen weitermachen.
Alles klar.
Ich gehe jetzt raus. War klasse. Absolut klasse. Nochmal, kann ich die Slides, kann man die irgendwo einsehen? Weil das ist alles ein bisschen klein.
Ja, die sind, du kannst dir das alles angucken. Die Links sind alle in dem Instructions-Dokument drin. Alles alle klar. Links für all das hier ist alles da.
Super, klasse. Sehr schön. Nochmal danke, war gut, war echt klasse. Ja,
ja, super.
Bis demnächst. Ne? Bis morgen.
Bis demnächst. Ne? Tschüss.
Ciao.